Hello? Oh, we're here. We're back. Okay, okay. Hello? I hear myself! I don't like hearing myself. Okay, there we go. Hello, everybody. My name is a Markiplier. That's not true. Okay, sorry for being late by 1 minute. Things got a bit scuffed in the last few seconds, but we should be good. I'm pretty sure Pink just made the announcement in BSMG, if I am not mistaken. Yeah, there we go. Okay. Sweet. We're in. I'm gonna make my live stream behind. Okay. Due to copyright reasons, we will only be listening to a cloudy sky today. Because I know for a fact that Sky doesn't content ID things, so I mean, you guys all know a cloudy sky, you're welcome. But let's begin. Okay. One thing I want to go over immediately. Do you guys hear me okay? I'm gonna wait a couple seconds for people to confirm that I am being heard. No issue with that? As in you can hear me? It's all good? Yeah, okay. Okay, we're back. Flag money. Okay, there's a little bit of delay. You sound good with a period. That's you had to put the period. Why am I live latency 20 seconds on my own preview? Give me a second. I'm gonna speed it up so that I can get. Or wait, no, the chat wouldn't have a latency, unless I'm dumb. Okay, one thing I want to go over immediately is that you should have a basic understanding of mapping before doing this. Like, kind of makes sense, right? Like, don't play modded Minecraft if you haven't played regular Minecraft. Like, don't try to make mod charts if you haven't made regular charts before. I'd recommend, like, having a good groundwork. Don't look at eBay! Don't worry about eBay. I can show this in a second. It's really stupid, but don't worry about it. I would have a basic understanding of mapping first, so like, because the thing for me is, I said this in the Beat Saber interview or whatever. Don't like, just lost my train of thought. If I'm playing a visual map or like a mod chart, if the mapping sucks, it doesn't matter how good the visuals are. I'm gonna not have a good time unless the visuals are really really good, which like you would need to carry with the visuals in order for it to be good. But I would recommend like getting a handle on mapping first. And also having an understanding of the JSON structure of map files. So what I mean by that is, I'll show you the input map first for my map for Extra Century. So we go into one of these difficulties here. Sorry, it looked really scary for a second, but if the first time you open one of these files, it's gonna like look white everywhere. And what you're gonna want to do is go down here. You'll see plain text, and then you're gonna be able to choose JSON so that it interprets it as JSON. You can configure file association for .dat so that you don't have to do that ever again. And the next time you open them, and then now when you open these files, you do Alt Shift F, and you'll format it like this. And what you're looking at right now is basically all of the data that makes up a Beatmap. This whole structure is called JSON. And I would familiarize yourself with JSON before, like that would be the ground level sort of prerequisite, I would say. Besides like being able to make maps, being able to understand what an array is, what an object is. Like this is an array. This is an object. This is an array of objects. So in the basic Beatmap, you're going to have these, for example, in the Beatmap, basic Beatmap events array, you'll have like all the events in here. And these will be like lighting events or ring rotation events or things like that. And then you're going to have the array of notes. And these are array of note objects. And in a vanilla map, you're just going to see like this flat, like this object with like a depth of 1, meaning that you're not going to have any other objects inside of that object. You're just going to have all of these properties here, and these describe like, okay, when is the note going to spawn? Where on the grid will it spawn? What kind of angle offset does it have? What color is it? What's its cut direction? And basically the goal of a mod chart, or how a mod chart works. Okay. Pink says that I should zoom in. Was any of that text readable? Should I go back over that again? I'm gonna take a look on my stream and see if the text is. Here, I'll zoom in a little bit more. Guess I gotta wait. This is probably good. So this is what a vanilla Beatmap looks like, right? The goal of a modded Beatmap, so this is my input difficulty. This is before I've done anything to it. I'll show you what the output looks like. It looks quite different. You can see there's a lot of things going on compared to the other. So first of all, you'll notice you have this new custom data object. Like this is a color note. So before you could see like, looked like this. Now we have this new custom data object inside. And basically custom data is completely arbitrary data that you can store in various objects. So you can store them in notes, you can store them in walls, you can store them in the whole difficulty, you can store them in the info.dat, you can store them probably in other places. I think that's it. But custom data has properties inside of it that are like completely arbitrary. So like if I just do this and like set a random value in here, like the game won't crash if I do this. But if I do it here, the game will complain because it's like invalid data, like it's not expecting this. But custom data is something patched in by mods that will allow you to put any sort of arbitrary data you want to store in there. And then mods like Noodle extensions and Chroma and Vivify will interpret certain keys in here, certain objects in here, certain values in here, in order to do certain functionality. And the reason you see people using scripts and that sort of thing is because doing it manually inside of the JSON file like this sucks. You can do it, but it will take, I mean, you can just look at all this stuff. This is like, you do not want to be doing this manually. So instead, what you usually want is a workflow where you have your map that you're doing in your editor, like you're mapping something in your editor, and then you run the script. And then through your script, you're taking whole sections of songs and applying data to it that you want to have the mods react to by adding this custom data to it. And then that ends up somewhere else and that's the final like mod chart map, right? And that's like what we call a non-destructive workflow, is if we have that input-output thing. Because if you were to just run the script on the same difficulty, and have it save back in on itself, then that's destructive, meaning that like your changes are irreversible. They're writing over themselves. So that's why we want to do the input-output structure, where you have a whole difficulty where you map in ReMapper, and then it goes through a script, and out comes all this custom data. And then you just keep taking the input and overriding it onto the output as you iterate through, like as you keep working on the map and running your script. And there's a couple setups you can do for generating this data. I mean, like you can just crack open a JavaScript script and just like start adding data by using JavaScript, and that's more or less what Mawntee's script is doing. So I'll show you. I should be able to put this link in the chat. Mawntee has a script set up which is very basic and very brute force of like we're going to add data through a JS file, and here's all the possible functions that might be useful. I'm going to show you where to download it. Where do we download it? Script download. Maybe there. So then, yeah, in releases, you would download this script. Yeah, whatever. And what the point of how you would use this is you would have a there's a whole README. I'm gonna kind of go into a shallow explanation of what this is doing, because this isn't my preferred workflow, but it is an option for those who are less like who are less used to programming, and really just want things to work, or who want examples right front and center. And because the other option I was going to suggest is ReMapper, and I'll get into that later. And there's two reasons that you might want to use either. The advantage of Mawntee script is that he has all of the functions like right here ready to go for you. For me, I find I get overwhelmed by all of the things that are in the file, and I want to start from a clean slate and then build up. But other people enjoy having things there and copying, pasting them, and modifying them. So what you want to do is up to you. I'm gonna go more into ReMapper, so you can give ReMapper a bit more of a chance later. But for now, like Mawntee says, tap K, hold Control, tap K, and then tap 0. So we're gonna collapse all these regions, and you would set the input and output, from what I understand, to like the difficulty that you're mapping in ReMapper, and then the output difficulty, like I said before. Oh, a message got deleted. And that's sort of like your non-destructive workflow, right? Like this is where you map in ReMapper. This is like the name of the difficulty file that you map in ReMapper. And then this is the output difficulty with all the modded stuff. And then in this script, you're basically just responsible for adding that custom data in. And how you want to add that custom data in is completely up to you, like what your goal is, whether you want to, how you want the notes to move, how you want to animate things. And that's when you need to look into the documentation for Heck and Noodle extensions and Vivify and try to break that down. And look at various script examples and see what people are doing, what kind of custom data they have. So the Mawntee script is an option, is what I'm getting at here. The other option is ReMapper. So I'll show you how to set up ReMapper in a new project. There is a setup guide on the ReMapper wiki, or on the ReMapper wiki. So if we go to the ReMapper repository, I'll paste this in chat. If you go to the wiki, here's how you can install everything. I'm not going to go through the install process because it's, literally like all written out for you right here. I'll show you how to set up a map though, because I need to set up a map anyway, so it makes sense to do. First thing I'm going to do is make sure you have VS Code installed. I guess that's part of the installation process. I'm just gonna open any of these files, like expertstandard.dat or something. These old files are lingering here, and I'm going to click on this Explorer tab. And I'm going to press open folder, and I'm going to, what the folder I'm actually going to select is the actual map that I'm working on, like this. Select folder. What that's going to do is it's going to start a VS Code workspace. So I'm going to have my whole map, my map files in the hierarchy here, which is really useful. And if I want to save this workspace so that I can just open it back up again, you can go to File, you do Save Workspace As, you just save the workspace. Now next time I open the I want to open this project again, I can just double click, and then there we go, everything's there. It will also save like where you have Windows docked and everything, which is very useful. Okay, so right now this is just a basic project, a basic map project. And this is like in my custom WIP levels, so I can access it through ReMapper. So all of your Unity project, I would suggest having your Unity project, your scripts and everything in the actual map file. And how this is going to work is that it's going to run through the map files here and it's going to generate a new map somewhere else. During the installation process, you're going to set up a playlist that's going to be for your output maps. But for now, I'm going to show you how to set up maps. So during the install process, you should have gotten a tool called RM Setup. So in the command line here, if you didn't see that, I went to terminal and then new terminal. Or actually, I clicked here, so I lied. Either works. And we're going to run this setup command. It's going to ask you, would you like to set up this project for multiple difficulties? So what this means is... Yeah, I mean, it's pretty self-explanatory whether you're going to have multiple difficulties that you're modding, like whether you're going to have down maps and stuff. I would almost just pretty much always say yes, because it's kind of going to be difficult for you to set it up later if you want to, but I just have it there as an option. So let's set it up. Would you like to set up the project for Unity/Vivify? I'm assuming we do, because we want to, this is a Vivify tutorial. So let's press yes. Would you like to set up Git? So for a bit of an explanation on what Git is, if you don't know, I have found it extremely useful during the process of creating maps, or creating Vivify maps. It allows you to incrementally make changes to your map in these things called commits. So you can basically snapshot your map at certain times, or not snapshot, but keep iterating in terms of small changes. And then if you somehow screw everything up in your project, you could just revert to the latest checkpoint, right? The latest commit you just made. So I find Git really useful. I'm not going to go over Git right now, and I'm not planning on actually working on a map, so I'm going to say no. But I would recommend looking into it. It means you really cannot go wrong with your map. If you you can't lose it. You can't lose progress and screw up your entire project. I would recommend looking into it. It's really useful. And it adds this command adds the git ignore files. If you know what that is and you're wondering if you need to set that up yourself, it automatically adds all the git ignore files. So once we do this, I'm gonna start it's gonna open the Unity hub for some reason. Oh, it's something I haven't fixed yet. But it's going to start generating a Unity project here. That will take a little bit. And the nice thing about this as well is that we don't need to wait for the whole project to import. I'm fairly certain, because it's generating all of that right now. I am going to check pings while I wait. That's funny, I've got a ping in the Cloudy Sky server. Oh, we dropped the track list for his new album. Great. All right, we're back. Successfully set up new map. All right. The Drowning Cry is a great song. I'm gonna remove this project from the list because I'm about to show you how to add it. So now that we have the Unity project here, I don't think I want to go over the Unity project yet. So I'm gonna start off just by showing the script.ts file. Now, so we need to install that coding app, Unity Hub, ReMapper, and anything else. Everything you need to install, like I mentioned, is in this installation. It does not mention that you need to install VS Code actually, but you should install VS Code. But yeah, all of the setup steps are in here. I wouldn't recommend trying to follow along with me right now because I'm going to be going at kind of a breakneck pace. The point being that people can go back on the VOD. So yeah, here's the ReMapper installation. Okay, so let me break this down a little bit line by line here. First, we've got a ReMapper import. So we're going to be including everything that, this includes ReMapper as a library. So we can start using things from ReMapper. Bundle info is a JSON file that's exported by the Unity project, and we'll get in that later. The pipeline I mentioned before that you're going to have the input map and we're going to have an output map somewhere. The pipeline is kind of it kind of represents that whole thing. So you're going to create a pipeline, and then you're going to add difficulty. You're going to add your difficulty, and you're going to change your difficulty, and then the pipeline at the very bottom, you're going to export it to a location. And that's basically the purpose of the pipeline. All this is all Unity stuff. We'll get into a bit. This function here takes in a difficulty and processes it. So this is where we're going to be adding our custom data. Is what you can think of this as. So whatever modifications we make in here is what's going to end up in the output. We're doing multiple down maps here in theory. I'm not going to do those for now because it's going to complain. I'm just going to do export plus standard. And then here we're going to export to the output directory. And that's basically the skeleton of the whole thing. All right, so first thing we're going to do, I am going to start running the script. So to initialize like ReMapper, we're going to do dnon rm, assuming you installed the file watcher. Or you can just run like the script running command that will run it one time, and you have to run that every time. So once we start this command, it's going to start the file watcher. And what this means is that every time we press Control S, every time we save the file, even if there's no changes, it's gonna run the script and output to this output maps folder. So during the installation process, in your custom WIP levels, you're gonna make this new folder called output maps. And this is where you can see it's right here. So if I delete this and run it again, there it is again. This is where this is a playlist. This is going to show up as a playlist in game that you can actually enter. So if we go in game right now, I'm just going to go 1.29. Easier. Let's see. Oh, that's so loud. I'm gonna mute it. Wanna enable autosave. You mean, so what do you mean by autosave? Like a feature in Visual Studio Code where is there a feature in Visual Studio Code where it automatically saves the file every so often? Not quite sure I understand, but I'm not familiar with that. I prefer to explicitly. I mean, you can do that. You can do that. I would prefer not to. By the way, turn on your headset. The audio is fine. I mean, there's going to be no audio in this map, so it doesn't matter. Probably not. Yeah. Okay. So here's our output map that we just made, right? And one thing you're going to immediately notice if we're trying to do anything with Vivify, or you're not going to notice because there's no lights. I'm going to turn on static lights real quick. Normally this would be a sin, but I need to demonstrate something. So the base environment is still here. So if we want to add new things to this map, we pretty much need to get rid of everything that's already here. Or we're probably going to want to. So the first thing I'm going to show you how to do is removing the environment. So what we need in order to adjust the environment is we need chroma. Because chroma does the environment stuff. So there's a thing in chroma I'm going to bring this up. So here's the heck wiki. Manual save is better anyway, though. The conscious choice to save makes you acutely aware of all the changes. Yeah. We go to the environment thing. As you can see, this is like an example of the entire beat map. So I mentioned the custom data thing, how you can put it on the beat map. So if we go to like the output directory thing here, you have a custom data field on the entire difficulty. So if we were to add an environment array like this, I'm doing this manually for the sake of just demonstration, but we're going to do it with a script. This is where you could add in, oh my goodness, I have a lot of different things. This is where we can add in like environment statements. And ReMapper is going to abstract that away into, like ReMapper is going to do that automatically. So I'm going to show you right now, we need chroma in order to enable that feature. So let's do map.require, or map doesn't exist in here, my bad. Map.require chroma. So now we're going to have chroma in the info.dat. And in order for us to see that change, we need to save. And requirements aren't going to update in the level here. So we actually need to exit out and go back in. The installation process shows you how to hot reload maps. Or there's a workflow on the ReMapper wiki. ReMapper wiki workflow. So if you go here, there's all sorts of information here on how to set up your workspace, reloading maps. Take a look at this section if you want to know how to do that. Okay, so now we should have chroma required and noodle extensions apparently. I guess my info.dat already had that maybe. Yeah, okay. My input info.dat already had that, so it doesn't matter. Now we can do a thing called remapper.environment removal. This is a function built into ReMapper that is going to create environment objects for us based on an array of strings. So we're going to pass it a bunch of strings, which is like, for non-programmers, well, I would assume that you should know what a string is or trying to use ReMapper, or you can just look at what I'm doing and probably just figure it out. We're going to pass in a bunch of objects that we want to remove, basically. First though, for this function, we have two. Yes, we're using ReMapper right now. This is a ReMapper project. We've imported ReMapper up here. This RM object has all of the things on it that are as a part of ReMapper. So everything in here is a part of ReMapper. The first argument is we pass the difficulty we're working with, and then we're going to pass an array of strings. Now to get rid of the whole environment, we can capture everything by just using environment, and then there's some additional objects that are under an object called game core. This statement should remove everything. So if we save and then enter the map, and then we also have to reload while in the map, which is a little silly, but okay, it seems to not work. Let's see. Did I enter the right map? I did. I might have entered the wrong difficulty. No, we're good. Okay, there we go. I don't know. Thank you, Beat Saber. But yeah, there we go. Everything's gone now. So there we go. We've gotten rid of the difficulty, or we've gotten rid of everything else in the environment. So we can maybe just add a comment on this, like remove environment, remove entire. And I'm also gonna section this off and say like info like that setup. All right, so I want to do a brief overview. Oh, did I forget to reload? I don't think I did. Whatever. Now if we want to do, I'm gonna do a very basic Notemod example. I think I'm gonna do an example of how to do some note mods, because currently our difficulty is empty and has no notes. So I'm going to go in the editor and I'm going to place some notes. And then I'm going to show you how you may do some basic note mods. So here's the map. Our output folder is where the output map will be. Our WIP levels is where our input map will be. We're going to go in here. I called it output. I probably should not have done that. Also very possible that my okay, no, my jump distance is okay. I thought maybe I screwed up, but we're good. All right, let's place some basic note mods down or something, or basic notes down. So now we're going to save, and we're going to move this to the output, and then if I reload, I should see some notes here. There we go. All right. So let's do a very basic note mod where we are going to have notes start small, like they're going to start with a scale of 0, and then they're going to go to regular size. So in order to do that, I'm going to give you a quick sort of overview of like how we would do this in the actual JSON, right? So for each of these notes, we're going to have to add a custom data. Like I'll show you just for demonstration purposes what it will look like in the custom data, but we're not doing this manually. We're going to do it through ReMapper. But in theory, the end result we want. We're going to use custom data, and then in order to do animations on a note, we use something called the animation object that Noodle Extensions implements. And there's various properties we could animate here. The one we're interested in is scale. All of these are on the wiki. So if we go to the wiki and we go to animations, I'm going to open OBS again. These are event types. Individual path animations. So you can see we have this animation object, and then we have certain properties that we can animate here. So yeah, anything assignable through the path animation event, any of these properties, we can use. Scale is here. Scale may look something like this. I'll give a breakdown of how this works. So we're going to have a scale property here. And how the scale property works is we're going to have an array here, and then we're going to have a bunch of smaller arrays inside. And these arrays are basically going to act as keyframes, right? So we're going to have the values that our animation will be at a certain time. So think about like when you're in like After Effects or something. You're going to have your keyframes on the timeline. So each individual keyframe stores what time it's at, and it also stores what the value of what you're animating will be at. So if you have like opacity, maybe you want it to fade in. So you'll have a keyframe at time 0, which is a value of 0 opacity, and then you'll have a value at like 1 second in. So then the time value would be 1, and then the actual value would also be 1 because you want it to be 100% opacity. So it works similarly here, where we have our values that we want the scale to be at a certain, and then we have the time that we want the scale to be that value. So for example, we want it to start off with 0 scale. So on all 3 dimensions, X, Y, and Z, we want there to be 0 scale. So we specify that here in the values, and then we need a time value. So it's good at the very start of the note's life, it's going to be 0. So right when the note spawns in, the time will be 0. Notes get hit at time 0.5, and notes despawn at time 0 or at time 1. So if we want the note to be big by the time it gets to the player, probably a little bit before, we'll set the time to 0.5, and we're going to set its scale to 1 on all axes, on every axis. So we can now do that, and if we reload, I think the very first note is going to do this. Oh, never mind. Did I include noodle extensions? Uh-oh. I did not include noodle extensions. My bad. I need to do that. So we're going to require noodle extensions as well. And now it's going to override the work I just did. But, or no, I did this manually in the input difficulty, so it's not going to override it. It's going to carry it to the output. So now we should have noodle extensions here. And you can see the very first one. You can see how it started small and then zoomed in. Now, I don't want to do this for every single note. Like, if I really want this to work for every single note, I have to go and paste it into every single one of these, right? And that's kind of a pain. So that's where the script workflow comes in, because what we can basically say is I want to add this data to every single note. So how we're going to do that is we're going to access the map object, and then we're going to access all of the notes on the object. So this all notes array includes, you can see the type is any note, it's called. So this includes notes, bombs, chains, and arcs. We're going to be this is going to be an array of all of them in the difficulty. So imagine like a big array just like this, but instead of just like this. But instead of including only the notes, it also includes the bombs, obstacles, sliders, and burst sliders. And then we're going to use a built-in JavaScript function called for each. So this will only work on arrays, right? So if I can give you a quick example. If we have an array of 2 objects here, on this array we can do for each, and then we have our element, and if we do like console.log e, basically what we would get in the log is 0 and 1, because it's going to run this function for each element. The element being first it's going to be 0, then it's going to be 1, then it's going to be 5, or we can just keep adding things. But in the case of the for each for this, for the all notes here, we're going to be going through all the notes. Can you set it for only a section? Yes, I'll show you how to do that in a second. So I'm gonna run code on each note. So we're defining a variable here, saying like, okay, this is going to be any given note through all the notes that we're running code on. So we have our note here, and we want to add our animation to it. So we can access the animation object like this, and we can say .scale, and then we can assign it. So just like we would in the JSON, we're gonna write our animation data here. And so you can maybe understand now that like we're going through each note programmatically and setting the animation, setting the scale. And you may notice there's no custom data here. When I'm writing the note data, I have to write custom data. I'm also going to remove this to show that I am actually adding it programmatically. ReMapper takes away the custom data thing so that you don't have to deal with it, because it's kind of boilerplate for the sake of like workflow, right? Like there's really no, it doesn't do anything. It doesn't really organize anything in terms of your workflow. So ReMapper will take that away for you and then add it on when it's outputting. So you don't have to deal with custom data when you're in ReMapper. Everything you can set on the note is right at the base level. So there's even a couple things that aren't necessarily in custom data. So like reaction time calculates the offset and like calculates certain other properties. So everything you could set on a note is going to be like right here. In the animation data, there's also stuff in here. And that's kind of the nice thing about ReMapper, is it just shows you straight up everything, and it has a description for everything, and then it also will scream at you if you type it wrong. So like if I try to do scale and I forget the time value, it's going to be like, hey, you can't do that. Or it should. I don't know why. It should. Dino. There we go. It's going to scream, but it should have screamed there as well. Whatever. This is TypeScript, which is a subset of JavaScript. So basically, it's JavaScript, but with type enforcement. So you can't like set a variable that's supposed to be a string to a number. So if we run this code, you'll see that every single note has this animation now. And that's the gist of like doing basic note mods. If we want to run it on only a section, just like someone in the chat requested, this is just a code block where you can do anything, right? So if we really don't want to run code, we can just say like, for example, if note.beat is like greater or equal to like 6, so anything past the beat of 6 we can just or return. We can just stop the code. So now I don't know what the times of my notes are. So there's 3, 5, 6. So the last note will not, or the last 2 notes are not going to get it in theory. So if we run this code again, the animation, and then yeah, it does not apply to those last 2. So, but you can do this better actually, because there's a built-in ReMapper function for this. So there's rm.notes, or yeah, rm.notes between. There's all notes between. There's color notes between. There should be more, but we do all notes between. Pass in the map. Pass in the minimum. So this is going to be the start of your section in beats. So say we want to do between beat 3 and beat 4. Then we have our function that we're going to run on each note, and then we just do the same thing again here. And that's a little. These are going to do same sort of thing here. So this is the minimum time. This is a maximum time. Yeah. All right. You may notice sometimes, for example, okay, let's see if, for example, on the properties, there is, for example, where are we? Objects. There should be a spawn effect thing. So you can turn the spawn effect off. But I don't. This is not. I thought it was in here. Okay, it is. I don't know what happened. I got trolled by the wiki. Spawn effect. So for example, there's gonna be, for example, the spawn effect thing. And let's try to do that in ReMapper. So note.spawn effect. And if we try to do this, or I think there's disable spawn effect. Or let's try spawn effect. You'll see property spawn effect does not exist on any node. Property spawn effect does not exist on color node. Okay, that was the wrong one. I think I changed it to disable spawn effect. Okay. Property disable spawn effect does not exist on any node. Property disable spawn effect does not exist on type arc. So what this is basically saying is when we're iterating all the notes, all the properties that are going to show up here are only all the properties that exist on every type. So they exist both on notes, bombs, arcs, and chains. So disable spawn effect exists on notes, they exist on bombs, and they exist on chains, but they do not exist on arcs. So it's going to give us a complaint saying it does not exist on arcs. In order to convince TypeScript that we are not going to try and put it on an arc, we have to do something kind of funky here, where we're going to say, okay, let's only run code. We're only going to run this code. Let's say equal to true. So we're going to disable the spawn effect. We're only going to run this code on arcs. So we're going to say if the note, if not note instance of rm.arc, and then that error will go away. So if the note is an arc, this will be true, and then we flip it and it becomes false. So this code will only run if it's not an arc, and then TypeScript will be convinced. So if you're ever looking for a property and it's not there, this is probably why. You can look at the error and then figure out like what you need to narrow. that's sort of a basic rundown of Notemods. There's more things you can do within Noodle extensions I'm not going to get into right now because I'm already spending a lot of time on Notemods, which isn't really the focus. There's animations where you can do animations just like you're using an animate track of it. And there's the whole like track system where you can kind of generalize animations for multiple notes and affect all of them at the same time through like things that run per each object's lifespan or over just a fixed period of time. And that's all something you can explore like on your own time because I want to get into some of the Unity stuff shortly. All right. I would like to get into Unity now. I'm gonna keep my my whole setup here. So you'll notice that like you should have downloaded the Unity Hub. So when we set up the project a while ago, you'll see these messages: add the testing Unity folder to our Unity Hub, add project from dist, download Vivify template. So we're gonna follow these instructions. So let's go to the add thing. Will node iterator be covered? If we have time, we'll go back after. Remind me. So I'm gonna look for this project so I know where it is here in this folder. So I'm gonna go to that folder. I'm gonna select the Unity project, and then it's gonna be added to our Unity Hub, and then I'm gonna open it. This should be pretty much instant, or pretty close to instant. Yeah, there we go. It imported everything for us right away. So here's our base Unity 2019 project where we're going to be doing our Vivify stuff. The only thing that's missing is we need the package in order to export the bundles and have it interface with ReMapper and all that fun stuff. So we're going to click this link. It's going to take us here. I'm probably able to combine this with my other thing. Thank you. And the setup instructions, create an open Unity project, we already did that. Download Vivify template from the latest release. So we're going to go here and we're going to choose. So the graphics in 3D, everything is mostly by code. You will see. That is a loaded question, but not entirely. What if I don't want to target BS 1.29.1? Can I use a more modern editor version? So we're in a bit of a tough spot right now. This project will export to Unity 2021. Using an editor that's later is not possible because we need to. They're forwards compatible, but they're not backwards compatible. So we can fix a 2019 bundle to work in 2021, but I don't think we can fix a 2021 bundle to work in 2019. So we have to build in 2019 for both versions. As soon as 1.29.1 is dropped, like people stop using it, I really want to move to the 2021 editor because there's some bugs with the 2019 editor apparently. But this is what we have to do for now. For Quest support, it's a bit different because we literally cannot build it in 2019. So we have to like set up sockets to like access a 2021 project, and it's like kind of silly, but like it's the best we can do for now. So you are kind of stuck on the 2019 editor for now. But you will be able to support later versions of the bundle, of course. The exporter will handle transferring the bundle to 2021 and 2022 and beyond. But we're going to install this project now. So we're going to go to releases, and there's various modules that we can set up. So I go over like different modules. So we have the exporter, which builds the assets. Then we have utilities, which handles, which has like a whole bunch of things that might be useful for you. Then we have examples, which is really good to look at if you're first getting into shaders, and you want to know how to build them, or how to use things in the utilities module. Bear in mind, some people are also locked into 1.29 due to CMVR issues. Yeah, that's what I've heard. There's scoring issues on versions past 1.29 due to OpenXR or something like that. So I think we're waiting on an actual fix from Valve I think that's from what I understand. So it's kind of a sticky situation. So it's not as simple as just dropping it. Otherwise, I would have loved to drop it because having 2 projects for having to use 2019 is pretty brutal. So for this demonstration, I'm just going to download everything. This Unity package includes everything. And all you need to do is, I have other stuff in here. All you need to do is double click on this, and then it will literally show up this import Unity package thing in your current opened project. And then you just press import. Okay. Wait, why are we playing a Zavi song? Oh, good Zavi and a Patty side. Okay, got it. Oh, whoopsies. That's probably fine. What? Copying assembly from script assemblies, Unity engine. Uh-oh. That's not good. I'll have to look into that later. For now, we ignore. There we go. Something in the utilities. I just reset Unity. Okay. Oh, so I can restart Unity, and it'll be okay. Well, I guess we're gonna have to do that. I mean, normally, if you're watching the VOD and I've made this fix already, you probably don't need to do this. But I'm gonna see if Echo is right. Thank you, Unity. Yeah, I don't understand. Like that does not happen in the in the dev project. So like whatever. Okay, we're back. Thank you, Unity. That's great. Okay, so very first thing we're gonna do, set up project, and it's gonna freeze your project for a bit, and then it's gonna do stuff, and then it's gonna scream again because it's stupid. Oh my god, is it gonna do that every single time? It looks like another. I just closed it. What are you doing? Now it's test runner. I don't know what test runner is. I don't know where that came from. Whatever. I tried the UMap today in multiplayer for the first time and nothing loaded. Yeah, multiplayer is not really supported. Build configuration window. Okay, we're gonna get this nice little window here, which is pretty self-explanatory. You can just look at all the versions you want to export. You can look at all the settings you want. Should work now. Okay, perfect. Thank you, Echo. Okay. So you're probably staring at this and wondering, how do I, like, okay, I've got an empty scene here, but like, how do I make visuals and like bring it into Beat Saber and make it look nice and do all this crazy stuff that I see in Extrasensory? And like, how does Beat Saber interface with Unity? How do these two things come together? And I want to start off by giving a bit of explanation of what's actually happening with Vivify. So, I'm going to get into this later, but this Unity project is just going to be used to export things called prefabs and materials. And those are basically going to contain objects that you can like instantiate. It's called. It's basically make an instance or like bring into Beat Saber. And you can use them. You can use them however you want. You can place them anywhere. You can use them as the notes. You can use there's all sorts of functionality you can use with prefabs. And then there's materials. So you can apply a material. A material basically describes how something looks in Unity, and you can also use it as like a post-processing effect. So you can add a material to the camera through custom events in Vivify. So instantiating, creating objects, adding them to notes. Like creating custom notes and stuff, adding materials to the camera, that's all done through custom events. And so I can show you what custom events are. You're gonna see this this custom data object in the difficulty, and and usually there's also a custom events array that includes like. If I show you what like the output of my map looks like, actually this will probably be more useful. I'm gonna go to No, I organize my projects pretty obsessively, actually. So in this custom data array, you're gonna see here custom events. So assign path animation, that's all noodle stuff. So I'm gonna try and find one that's Vivify. Oh, okay, we're still in Notemod land. Okay, here we go. Set material property. So for example, here's what a custom event looks like that's using Unity. Assets. So for example, we have like data pointing to the certain material we want, and then the properties that we want to set. So that's an example of like the set material property event. There's other events going on. I want to find instantiate prefab. Here we go. So if we want to bring something in from Unity, we build basically what's called an asset bundle, and then the asset bundle includes all prefabs or materials. And then Vivify accesses prefabs and materials and like brings them into the Beat Saber world from the asset bundle. And this little window is responsible for making the asset bundles. And then in Unity, you add things to the asset bundle. Yeah, so okay, basically basic script knowledge is necessary for creating a map using Vivify. There's levels to it. So you can go in and write all this stuff manually in the JSON like that, right? And that doesn't require any scripting knowledge. You can just look at what people are doing and like copy and paste and add data in here. But that can be pretty cumbersome. Like I demonstrated earlier in the VOD, how you, for example, may want to add an animation to every note, like having to go through and copy and paste it, and then you add new notes in the editor, and it's like kind of a pain to have to go and add them to every single note. So I'd rather have a workflow where it adds them automatically, and that's when you need to get into scripting. And ReMapper is like just a more convenient way to do that. But you can also make your own like JavaScript file and automate it. That you can automate it however you want. If you want to automate it, likely you want to automate it if you want to be efficient. So it depends on what your goals are. Pretty much mixing gaming development with mapping. Like I said, there's multiple approaches. If you want, I'll get into this later. In Unity, you can make all your assets yourself, or you can just find free assets and import that into a map. You will not get around having to like position things with numbers. Or you're not gonna get, actually that's not true. That's not true. You can position things in Unity and then import it. You're not going to get around having to deal with like this data and understanding it in some way, shape, or form. The way you put that data in there is up to you. I prefer a scripting workflow because I'm comfortable with it and I find it fast. And there's a lot of safety that I can put around it to make sure that I don't mess anything up. But whether you want to go in and raw dog it and just place custom events in the difficulty yourself, that's up to you. I would recommend giving it a try because I think that I have so many examples on my wiki. There's a ridiculous amount of examples. Not only is there a ridiculous amount of examples on my wiki here, there's also an entire there's an entire map example I gave you. I released my project. Just objects to export into mapping. Yeah, basically. What was I going over? I was going over, okay, how do you want to make visuals inside of Unity? I'm going to give a little bit of a breakdown of, because one of the first things that confused me when I was getting into Unity was I was like, how do you make visuals in a game? Like how does a game work? And I would go onto like shadertoy.com. Like, if you guys have seen this website, ShaderToy, hold on, I headed there right now. You see this insane stuff, and you're just wondering, like, oh my god, it's all this math, and it's like, how do you even do this? Like, how are people creating this stuff out of math? I'm just going to come right out of the gate and say that, like, all of this scared me at first, and like I was like, I need to know how to do this in order to make visuals. That's not the case. The big distinction between ShaderToy and Unity is that ShaderToy has no 3D renderer. Like, you don't get to like place objects around. Unity has a whole thing, right, where you can make objects and then you have like a little gizmo that you can move things around. And the rendering is done for you. You don't have to project things onto the screen. You don't need to deal with all the math for that. All you need to do is say where my cube is, or like drag it around in the editor. So it's a whole different ball game. The only way it does get similar is when you're trying to actually figure out how the cube looks. But even then, you can use somebody else's assets if you don't want to figure that math out yourself. And I'm going to go into that later. So don't be alarmed by like looking at Shader Toy and saying that you need to understand all this math in order to do it. That's not the case. I don't understand what's going on here. If I'm looking at this, I would have to dissect this for hours before I understood what's going on. So don't worry about like trying to understand this stuff. Unity is way more friendly than that. Because like if I really want, I can just make a cube and then like I can bring this into Beat Saber and then that's it. Like I didn't have to do any math to project this on the screen. If I wanted to do this same, if I wanted to make this same scene on Shader Toy, I would have to make my own 3D renderer essentially. Which is, so it's a completely different ballgame. But something you should understand is what is even happening, like when I'm looking at this cube. Even though there's several shaders or effects made for Beat Saber already. Exactly. There's plenty. I'm going to go over some shaders that you can use right out of the box. But I'm also going to go over like an overview of how to make your own shaders if you're interested in that, because it's a challenging but rewarding process. Can you use Amplify for shaders? I'm fairly sure you can. Okay, so I'm going, in case you don't know, I'm going to blow your mind a little bit. So this is a sphere, right? Never done any code or scripting, but I know how Unity works to some extent. Yeah, exactly. You just need to know how Unity works, and then you just need to figure out how to use the events in Beat Saber to like move things in, or just lots of examples from ReMapper that I'll show you how to do right now. This is a sphere, right? Except it kind of isn't. Everything that you're seeing in a game is made out of triangles. So, like most of the visuals that you're going to see in a game, right? This collection of triangles is called a mesh. And a mesh, it basically just describes where the triangles are. And then you're like, okay, so great, we have triangles. So what do we do with the triangles? If you want the triangles to look a certain way, that's where shaders come in. So you have, I'm going to make quickly like a materials folder. In Unity, you're able to make a material, my ball, and you're able to put it on like this. And then I can like change the color of the ball and do all this stuff to it. And what it comes down to is that the shader is taking the information of the triangles and turning it into visuals. By like getting like, okay, if I'm it goes through each pixel that the sphere occupies and is like, okay, where am I on the mesh? What's the upwards facing direction of this surface? What does the sky look like? And then it takes that information and outputs a color. And that's all a shader is. So how you're going to achieve that, you can either use built-in ones, or you can use ones that other people made, or you can make one yourself. But for now, we're just going to use the Unity standard one. Yeah. All right. The only issue that I need to go over is that the Unity standard shader does not work with Beat Saber. And I'm going to have to give a little bit of an explanation why. So your display in the game is displaying colors, right? And you may be familiar with red, green, blue colors. So like RGB colors. Every color is made out of a red channel, a green channel, and a blue channel. But there's also an invisible channel called the alpha channel. And the alpha channel sort of stores like an arbitrary information. And in most cases, alpha is used to store transparency. However, Beat Saber decided that alpha will store the amount of glow. So this shader is outputting 100% alpha, which means that it's... How do I describe? All of the pixels here are going to be 100% on the alpha channel, and then when you go into Beat Saber, it's going to be like, oh, alpha means glow. So the whole thing is just going to be white. What am I saving right now? Oh, I'm making a scene. Soon you still have to do textures in Substance Painter or something for these, or use shaders that can do certain things to add depth. Yes. So literally everything you decide to do is through a shader, right? So if you decide to use Substance Painter or anything, you're making a texture, and that texture is being fed into the shader, and then the shader is responsible for using that texture and displaying it on the screen properly. I can show it in Beat Saber, so let's do a quick overview of prefabs, or maybe I'll just do this very simply. I'm going to make a new folder and call it prefabs because I'm organized. I'm going to call this like my sphere. And what I'm going to do is I'm going to drag it into the project view here, and it's going to create a prefab. And you can see how this one turned blue because now the source of the object is now here, and this object in the hierarchy is referencing this object. So I can delete it and add it back in, and it'll be the same object, and I can create multiple different instances of the same prefab. But if I go into the prefab here and like, I don't know, there's not much I can actually demonstrate. If I add like a cube onto it or something, you'll see that all of these also have that change because they're referencing this prefab. So basically what Beat Saber is doing is it's doing what I just did in the editor, but like through an event. So you can spawn in a prefab, an instance of a prefab, and just specify its position. So this prefab is in our project now, but it's not part of an asset bundle. So when you look at the bottom here, you're going to see you can add it to an asset bundle, and we're going to make a new bundle. We're going to make a new bundle name and just type in, except for this UI sucks, so I have to exit it for some reason. In order to type. So there we go. We're going to add it to the bundle. And then in our build configuration, see how it says bundle to export, bundle. These names can be anything as long as they line up and you add everything to the same one. And I'm just going to do Windows 2019 because I'm fairly certain I'm in 1.29 right now, and that's using Unity 2019. And I can either press this build option, which will open up the build window, or I can do the quick build thing where if I press F5, it will build a working version. I don't know how that was 2021. It should have been defaulting to 2019, but oh, I think because I've opened this exact project before. If I press F5, it's going to build. Except for, okay, you know what I need to do? I just realized I realized that I have preferences left over from when I was testing this earlier. So I'm going to clear all player prefs, which is going to basically this is going to be a fresh project, like in terms of the settings. I had settings left over from when I was testing. So now it's going to properly say, hey, you need to set up. There we go, we're set up. And then now if I press F5, it's going to ask me where I want the bundle exported. I want it in my maps folder. So if I do that, it's going to export to my maps folder, and then when we go in my map folder, you see this bundle Windows 2019.vivify. When making sabers, why can you export the saber, which is basically an asset bundle, without doing the extra when making sabers, why can you export the sabers without doing the extra steps for each prefab? I'm assuming because you're using a saber project that's already set up to look for a specific prefab, so you don't need to do any of that other stuff. It's automatically like looking up for a specific object. Yeah, makes a prefab for you. Yeah, exactly. So now we have this bundle in here, and also our bundle info.json will be updated. And one thing you're going to need to do every time you export and you add like a new object to the bundle is you're going to do Control-Shift-P and Dino restart language server. If you've already just typed it in, it'll already be at the top because it says recently used, and then you just press enter. And this is going to tell Dino to like re-import the bundle info here, which will like allow you to use your prefabs in the menu. So let's do Vivify stuff. Now I'm going to want to add this prefab into the world somewhere. So you can see there's this prefabs object here that I mentioned earlier. This is basically a ReMapper wrapping around this JSON file and giving us some nice functionality that we can use to create instantiation, like creation events for the prefabs easily. So if I type in this prefabs thing, you can see our sphere is there because it was part of the info. It was part of the JSON file, and then it got parsed by TypeScript through ReMapper's types, and it shows up here. So we can use this, and we have all sorts of options here. We can access the name of it. We can access its path in the you can access its path in the asset bundle, so like where it is in the assets folder, and then we can also, this is a function that we can call. And this creates an event that will spawn the prefab in. So if we do instantiate and then we pass the map, it'll default to beat 0. If I press save and I reload, our cube will probably not be somewhere I can see because it's, or our sphere will probably not be somewhere I can see because it's probably at some crazy transform. Whoops. So I'm going to set its position as well. If you want to do any extra properties, like if you want to define any sort of like additional properties in the event, you can add an object here that will have all the options for placing the prefab, for example. So we're going to set its position to 0. And it's not there still. I think I know why. I remember hearing something about how the standard shader does not work in Beat Saber in the sense that it literally will also not show up. So, whoops. Okay. That is a good opportunity to get into the shaders other people have made that you can use for Beat Saber. First one I want to mention, or that Mawntee wanted me to mention, was Poiyomi. So Poiyomi is what we call a what do you call it? Poiyomi is a Uber shader, which is able to do a bunch of different things. An Uber shader like gives you a handful of options to achieve all sorts of different effects. It's basically a general shader. So I'm going to put this link in the chat that you can use. And we're going to go to releases, and we're going to download the Unity package here. Is Poiyomi free actually viable? Apparently. I don't know. And we're going to double-click the Unity package the same way. So the object will stay in the location assigned in Unity if you don't assign it in ReMapper. Yes. It will just use the prefabs location, all the default values, unless you override it. We're going to import this. Yeah. So that's what I'm going to go, show you now. Da, 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 da. Okay, we're still waiting. What? It's mitosis. Okay, there we go. Oh my god! Okay, I need to look into this. I don't understand why this is happening. Temp, Unity, test runner. Ah, can I clear that? Really? Can we ignore it? I will now ignore it. I pretend I do not see it. Don't do that, by the way. Don't ever click this button. Or I can keep it unlocked now. I think we'll be fine. Now that we go into if we go into the material, and we go to we go down to the material here. Or sorry, this is not the material. This is the prefab. This is the material. It doesn't matter. We could have still accessed it from there. You'll see Poiyomi is right at the top here. We can go in here, and you're gonna want to do. So Mawntee gave this to me. I'm not entirely too familiar. I'm fairly certain that he said Poiyomi Toon World. You only need if you want to use global illumination. Whatever that means. Poiyomi Toon, I'm assuming, is what you want for most purposes. So we're going to give him a second to compile. Thank you, Unity. Poiyomi, wait, this is caused by scripts. Oh, for... Okay, wait, I'm going to save this scene somewhere. I'm going to make a scenes folder. This is what you should do. You should make a scenes folder with an S. And we're going to call this seed. For the record, you're not going to be importing scenes into Beat Saber at all. Scenes are purely for your own organization. You can use Toon for most situations while the world is better for environments. Better for environments, like it uses environment reflections, or well, how does it work? Are you serious? Sharing violation. Oh god. Are we gonna have a problem? Nope, we're good. I'm no longer paying attention to it. I'm gonna have to investigate that after stream. Okay, so we've got all sorts of things we can change here. Alpha cutoff. I don't know. I don't know. You can mess with all these things yourself. It's pretty self-explanatory. One thing you need to do after you're done messing with things is you have to lock the lock-in, which basically means, from what I understand, this is when you're making like an Uber shader like this. There's all sorts of these. There's a bunch of options, and most of these are not. Most of those options are not going to be used. Are going to be set to default, and in that case, they can be stripped from it. So when you do lock-in, you're basically like all of the things that you change get baked straight into the shader, and everything you're not using gets yeeted. So it optimizes the shader so that it's not taking up so much memory by being so big. If you want to animate things in like an animator or through like events in Vivify, then you should right-click and do animated. And that will allow it to not be baked in, so you can actually change it. Okay. All right. So, in theory, if I now press F5 again, I don't even need to be in this window to press F5. I can just press F5. Except for it's not going to work because what's your problem? Copying assembly from temp Unity to library. Okay, you know what? You know what? You know what? You know what? Okay. You know what? I'm gonna. This seems to be something to do with this folder. I'm gonna destroy this folder, and then it will now work. Oh, you're right. You're right. You're right. I forgot about the Beat Saber support. I'm sorry. I'm sorry. So yeah, I gotta enable Beat Saber support. Trust me, I'm very good at my job. So yeah, it's gonna be importing a bunch of things again, but like hopefully we shouldn't get an error anymore because I don't think that was my fault. I think that was Unity being Unity. Rewrite submission. Yeah, the glow issue I was talking about earlier, I believe it. Can't you just remove the testing the package from the project completely? Packages. Is there a testing test? I'm not sure. I've honestly never messed with that stuff, and I don't want to take up too much time doing it, but. Unless it's blocking me from literally being able to export, then that's kind of that's kind of rough. I'm not sure why that would happen. I'm hoping that it's something I did. Unity loading times, unfortunate. It will not be this bad every single time. This is a one-time delete packages folder. I might have to do that. I don't know. I think that's sharing violation. Okay, whatever. That's not an issue. If I press F5 now, is it gonna work? Hooray! Uh-oh. Don't worry about it. Okay. Materials. Optimize shaders. My ball. Okay, no. I need to unlock the shader, I'm pretty sure. And I should have done this first. You need to press this button. And then I need to go into my scene. Out of memory? There's all sorts of amazing things going on. Unity loves to be a mischievous fellow. Okay, we're gonna press F5 again. Oh my god! Oh my god! Oh my god! Okay, this is why I don't like using, I'm fairly certain those issues are from Poiyomi. But it's probably because I'm on 2019. But, oh my god. What do you mean share? Oh, is it because I'm in? I think I know why that was happening. I think I need to not have the level open. Oh, I can remove it. I don't think that's the error. I don't think it's what's causing the error anymore. I think it was an issue having to do with like creating the project. There's still a sharing violation. You need a specific version of Poi if you're going to use on 2019. This is karma for nothing going wrong during interesting. Yeah. Great. Can I build? Unlock shader was found. Okay. Okay. I believe it works. I believe it works. The window is not responding. What are you talking about? Whatever. Okay, we're back. We're so back. We're so back. Except for we're not back anymore because there's a bunch of fucking... This is a Poiyomi issue. This is not a Swifter issue. This is not a Swifter issue. I'm coping. It's not here. Okay, I blame Mawntee because he gave me links. It didn't work. So, where's Poiyomi? Bye. Goodbye. Goodbye. I'm gonna scream. I'm gonna scream. 9.1.2. Okay. I don't understand I don't understand this issue. I don't understand this. I don't understand why that's happening. I've never had this issue in my entire life. So you're saying window, package manager, and then there's in project. Est framework. Remove. Well, it's still not. It's still not doing it. I'm gonna restart the project again. Yeah, it works. Yay! Okay, we're not using Poiyomi right now. I'm sorry. We're not using it. Okay. Okay, if you actually want shaders that work, I'm pretty sure you can do 9.1.2 like Alex says. I've made a head out. Yeah, okay, thank you. You can try that. that was a shader issue. I have never had to deal with that because I've never used Poiyomi before. So we're just gonna make shaders ourselves now. That's what I wanted to show next. But if you want, there's pre-existing shaders for Beat Saber. I don't know where they are, but you can. There's like standard shaders that you can use that are specifically made for Beat Saber that people have been making like sabers out of for years. You can probably find those resources on like model sites, like Model Saber and all that. But for now, I'm going to do a rundown of how to make your own shader. Okay, so I'm gonna make a new folder and call it shaders. And if all goes well, I should be able to do create, shader, Vivify, standard, or bare bones. Yippee! This is gonna be my awesome shader. And I'm gonna open it, and it's gonna take a little bit because Rider is gonna open, and then Rider is gonna take a little bit. I would recommend getting Rider because Rider is very cool. And is very useful for shader development, and everything just blew up. And we're gonna try again. We're so back. Okay. Huh? Dude, my entire graphics card crashed. Oh. Oh my god. I have never had. How is this happening? What? We're still live, right? Oh no, the actual like stream is cooked. This has never happened to me before. This has never happened. Oh my god. This has literally never happened. No. Okay. Just my preview in OBS is bad. Okay, the stream goes on. I've never seen that happen before. Dude, like OBS is like I can't see my own preview in OBS. How do I enable preview? I cannot like see my own stream. That's so much fun. Okay. Okay. I'm gonna try and open it again. Okay, we're gonna work this time. Real. Okay, we're back. We're back. We're back. Oh my god. And my taskbar is. Oh my god, my taskbar is tweaking. Okay. I'm gonna recompose myself. This should never happen, by the way. Like, I've literally never ever seen this before. This is insane. I'm fairly certain it was Poiyomi that just somehow destroyed everything. That was insane. Okay. Okay. So, this is what a shader looks like, everybody. We're able to see. I'm gonna assume that's a yes. Okay. I don't know how I made an R twice. All right. We're gonna go line by line. This is the path in, like, when you're in a material and you see all this stuff. This is basically the path inside of that you're gonna store the shader. Yeah, it was a Windows moment. These are all the properties that are going to be passed from the inspector to the material to the shader by the material. So if you notice, we use like unlit color or standard. Standard. You can see there's all this stuff that we can pass into the shader. A material is basically like it's a container for data that you can pass into a shader. That's all a material is. Like, a material doesn't really exist on the graphics card. It just is a user-friendly way to pass data to a shader. So the shader is going to request a bunch of stuff in the materials here. Right now it's requesting nothing. We can write like things we want to request to be used in the shader. This is what that block is for. Subshader, I don't really know what this word is, I'm gonna be honest, but okay, tags. This is where we set like the render queue is the most sort of notable thing that we can set in here. So the render queue is like, when in the rendering process are we going to render this object? Are we going to render it before geometry? Are we going to render it after geometry? Are we going to render it during transparency? Like, everything gets rendered one after the other. So like, there's a sort of queue, which is a number, which determines like if a number is higher than another number, then it gets rendered later, and that's basically it. So I think geometry is 2000, and then transparency is 3000, which means that like generally you want things that are going to be transparent to be in the 3000. And then there's like aliases for those numbers, like shortcut words. So if we do like q equals transparent, then this is going to be rendered during like at the same time as other things. It's going to be rendered after geometry. Other things that are tagged as geometry. So it's all kind of arbitrary, but there's kind of standards being set. Okay, so we're going to start a pass. So you can have multiple passes in a shader. A pass is basically just like, you're going to go through this shader in a pass, you're going to go through the whole process of like making the visuals of a shader do their thing. So you can have multiple passes. For example, like there's some shaders that create outlines. So you have like the object in the middle where you have one pass where you just like make it black or something, like in Lifelike with the notes, and then you have another pass where you just scale everything by a bit and then make it white. Most things only require one pass. Okay, and then we have CG program. This is the start of our. You'll notice CG program and NCG. Everything inside of here is like a whole nother world. Okay, so like it doesn't know about anything outside of this. All this other stuff is like Unity Shader Lab. Everything inside of this is HLSL, and Shader Lab is going to pass things into HLSL, but HLSL doesn't really know about anything outside of that. So this is the actual shader program. First, we're going to define where our vertex and fragment shaders, like the names of our vertex and fragment shader functions. So I need to go over a little bit of the graphics pipeline with you. This is all. By the way, all of this is for if you want to make your own shaders. If you don't want to use pre-made shaders. So if we have this ball, or we're going to go into the scene with the ball. This ball, when this ball is being rendered to the screen, there's a list of like tasks that are happening. And at some point in that list, first the vertex shader happens, and then the fragment shader happens after that. So what the vertex shader is it's responsible for taking, like I showed before, everything is made out of triangles, right? And these triangles have vertices, right? So a mesh is made out of vertices, and then like triangles, which are like, okay, which vertices is this triangle a part of? So where these vertices are determines like the shape of the mesh, because the triangles just like point to a vertex and connect up. So during the vertex pass, you're responsible for taking the vertices, their positions, in relative to like the center of the object, or like wherever the origin of the object is, and then like moving it into the position relative to the camera, and that's called clip space. You don't need to do that manually. There's a function in Unity called Unity Object Clip, which will take like which will do all that for you. But the key thing is that it's programmable, so you can change, whatever the final position of the vertices of every single vertex on this sphere are is determined by you in the vertex shader. So you can add to the position and basically move the vertices wherever you want. So if I want to make this sphere like 2 times bigger, I can do that, because I can change the position however I want in the vertex pass. In the fragment shader, this is when all of the triangles are being drawn on the screen. So in comes all the information about like where is this triangle in the world. Basically, you can pass in information from the vertex shader to the fragment shader, and say like you can pass whatever information you want. You can pass like the number 1 if you want, but it's not that useful. So, but you can pass arbitrary information from the vertex shader to the fragment shader, and the fragment shader is gonna take whatever information you give it from the vertex shader, and it's gonna. I'm gonna make sure that I'm scroll all the way down in chat. Okay. And that's when you get to output a color based on all that information. So, for example, when we're looking at the standard shader, you're probably thinking like, okay, how are we getting lighting? How are we getting this color? So the color is passed in, of course, from the material during the fragment shader, where you have global access to that because it's from the properties. So you can just use that. The lighting information, the triangles, you can pass from the vertex shader to the fragment shader. You can pass basically the normals, which are like the upwards direction. You can pass like the local position. You can pass all this information, and then lighting can be calculated in the fragment shader to output a color based on all of the lighting, all of the where the triangle's facing, where it is in the world, that type of stuff. But you can really do whatever you want, because like I said, it's programmable. So whatever final color ends up on the screen is entirely up to you based on the information that you're given. So for example, let me do a very basic vertex shader. So I'm going to delete this sphere. I don't like it anymore. Yeah, this is why we stream. So let's add this material to our plane, and then I'm just gonna like save it as a prefab. Now, and I'm gonna make sure that I'm using my shader that I'm. Oh, thank you UI. Okay, so as you can see, we're literally outputting 1 in every single channel with this shader right now. So it's just white because red is white. Red is 100%, green is 100%, blue is 100%, alpha is 100%. So this will glow if we're in Beat Saber. I'll show you that right now, actually. Never mind. I forgot to add it to the asset bundle. Now I'll show you. Okay, so if we go into VS Code and then we actually start the program again, I have to restart the language server like I said before, and then now this is going to error out because this isn't going to exist anymore. It's going to be the plane instead. So now we're going to run the script. And then there we go, we saved. And then I have to restart my game because my game crashed because my entire graphics card crashed. Are you forced to make a new shader for textures? Made a standard texture and set the alpha to 0, but it was still white. Made a standard. I don't know the details of I don't know the details of like what your shader was doing, but no, you should. If you want to make a different, if you want, you can use the same shader and make multiple materials that reference the shader, and then each material passes in a different texture. That's kind of the intended use. Love your chroma mod chart maps. Can't wait to see them make next. Thank you. I'm gonna make cool things probably. Okay, so now we will hopefully see this. If we don't, then I'm gonna be very sad. Okay, I'm very sad. What is going on? What's going on, Unity? I mean, I'm in the right. I'm in the right version. I'm in the right version of Beat Saber, right? Let's see. 1.29. Okay, what's the big idea? What's the big idea? Where's my... Let me see if the event actually made it into the into the output. Instantiate prefab. Okay. Sir. Vivify requirement? I'm fairly certain I'm required. You might be right. Oh, you're right. I'm stupid. It happens to the best of us. Okay, well, we're quickly finding out that we need to require things. Okay. Yippee! And as you can see, it's glowing white. Because yeah, our fragment shader is literally just out. It's disregarding any information that we're giving it, and we're literally just returning 1 every single pixel. Okay, let's make our first vertex shader. I'm gonna zoom in. I'm gonna have to call you Professor Swifter after all this teaching. Thank you. Okay. All right. So basically, all we're doing right now is we're taking the object space. We're gonna open up MS Paint. Okay. This is how you know it's getting real. Okay. Here we go. So let's say we have like a cube or something, right? We have our cube. We have our triangles. This is too much information. This is too dense on information. A vertex like this may be like, if this is the center of the cube, this vertex is probably like at the coordinate 1, 1. And then this vertex is probably at the coordinate like -1, -1. Like think back to like early high school or whenever you learned about like coordinate systems, or when you're playing Minecraft and then you give somebody your base coordinates and you're like, all right, you got to go here. You understand coordinates. You've played Minecraft. So all of these coordinates are relative to the center of the cube. This is called object space, okay? Object space, okay? Um, in terms of our camera, when we're using our camera like this, um, this when we're looking at the, I'm gonna actually extend this. An object in. I'll look at that in a second. I need to get through my lecture here. Come on. This same cube, right? We have the same cube. We have the same vertice. Right here. If we're looking, if we're let's say our camera's here, right? Relative to the camera, the way we describe the position of this, vertex is completely different because now this is the origin. So like, this is probably something like -4, 1, 1. You know what I'm saying? Like, it's the same vertex, but it's just depending on where we put the origin, the coordinate is completely different. So this is clip space. So basically, the vertex shader is going to give you your vertices in object space, and then your goal is to export them in clip space. And that's what this does. Like, it literally just takes it from object space and converts it into clip space. But that doesn't mean like v.vertex starts off in object space, and then o.vertex has to be in clip space. But that doesn't mean that we can't change it. So I'm going to define a variable and call it local position. Or actually, I'm going to do 4 because I'm cool. The reason this is a float 4 is because a float 3 would be 3 numbers. A float 4 is 4 numbers. The fourth number, so it's like XYZ, the position is XYZ, and then the fourth number is W, which is used to convert it into clip space, and it's kind of confusing. So I wouldn't mess with, you have to keep that number basically when you're doing this function. So if I do this, it's going to do the same thing. Or if I go into Unity, it looks like the same. However, I can take like the Y value and like add to it or something. And then now like you can see how I'm taking the vertices and I'm like moving them up. And it respects the object space, right? Because it's relative to the object it's relative to the object. So I'm moving them up in object space. And I can do whatever I want. I can take like, okay, so for example, this variable here is literally just the amount of seconds elapsed. I can just like run this through a sine wave. And then if we just look really closely, and I also need to enable animated materials. Whee! Here, it'll just go up and down over time, which is really funny. And then on top of that, I can also like Desmos. Okay, so here's what we're doing right now. We have like sine t. As time increases, we're going up and down, right? But then what we can also do, I just realized I can't visualize this in 2D, so I'm gonna go to the Desmos 3D grapher and see how well we can do this. So we have t equals, or y equals sine t. Wow, this is not helpful. Oh right, because it's not gonna work. It's not gonna extend to 3D nicely. Z equals sine x, whatever. So this is how our height is. This is how our height is changing over time, right? Like as the height goes up and down, as time goes on, it's gonna go up and down, up and down. What we can do though is we can take the y value, and then like as the y value. This is probably confusing. I'm doing things the swifter way. What I'm gonna do, maybe this will make more sense to you. I'm just gonna add the x value, and you'll see that like as we go further in the x value, it's gonna change the phase of the sine wave. And then now, what did it look like before? Oh right, yeah. So this is the x value. As the x value increases, we're also progressing through the sine wave. So now we've got like a wavy thingy. And we can do whatever we want. We can just take that output value and multiply it by 5, and then now it's very wavy. We can multiply it by something less, and now it's not as wavy. But the point is that we are able to adjust where the vertices are. So like all of the points that are on the, like if I go into wireframe mode, all of these points, this is the thing that we're able to change in the vertex shader. I'm going to do a little bit of a funky thing. I'm going to do this similar thing, but instead of using the x value, I'm going to use the distance from the center, I think. So I need to see this in not wireframe. This is really hard to see because it's all white. I think I need to do XZ. My bad. Okay, so imagine we're changing the phase of the sine wave with like the length of like the distance, because this is 0, 0, 0, right? And then as soon as we start going out, like maybe this corner is like 1, 1, 1. So if we think of that as like a vector, if we get the length of that, it essentially describes the distance to the center. So we can use the distance to the center, this expression here, to like shift the phase of the sine wave. We can do whatever we want in the vertex shader. And like I said, it's programmable. You don't have to do anything a certain way. You just got to do whatever you need to get to the end result that you want. So here's a funny little thing. Now, when I mean that if we want to do something in the fragment shader now, make the color of the Y pose. Yeah, I'm gonna do that in a second. So I'm gonna show you that you're able to transfer information from the vertex shader to the fragment shader. So let's see, let's say for example, we want the height of the sine wave to be the color. So the higher up it is, the brighter it is. The lower it is, the less bright it is. So I'm going to extract this to another variable just to make this a little bit nicer for us. So we're going to do the same thing. We're just going to make another variable for it. And you can see it does the same thing. We just have this here. What we can do is this is our v2f struct. So this is like a little package in the mail that we're sending. You see how this function outputs a v2f and then this one takes one in? This is a little package that we can send from the vertex shader to the fragment shader. And we're able to put anything we want in here that we can pass. So SV position is reserved. Basically, anything you put in here, you have to line up with something called a semantic, which is basically like a little like slot that you can store information. SV position is reserved. Everything after that, you have to use something called text chord. So it starts at 0, and then you can go 1, 2, 3, 4, and just keep going up every time you need something new. So let's pass the height as text chord 0, like that. Now it's going to say like following members of UI have not been initialized. O.height. So yeah, we need to output the height, and we're just going to set it to the height that we just calculated. And we're going to go back in game, and it's still not going to display anything because we're just returning 1 still in the fragment shader. We're not actually using this information, but now in the fragment shader, we can access the height. So if we just output this, boom! We see things. Oh my god, that's so cool. Okay. So to explain what's going on here, the reason it's black past, like, when we're going below is because the number is negative, and negative light doesn't exist. So, like, it's going from 1 to -1. So we can change this. if we multiply it by 0.5, then the peak will be 0.5 and the trough will be 0.5. So it will go from 0.5 to negative 0.5. And then we can add 0.5 to that. Remember, order of operations here. This goes first and then this. If we then now the peak will be 1 and the bottom will be 0. So we basically shrunk it by a factor of 2 and then moved it up half. You can kind of visualize this like times 0.5 plus 0.5, right? So you see the difference. We're now moving our values in the range between 0 and 1 because that's the range that we get to export. And now we get to see the effect, and the black is only at the very bottom. Boom. And you're probably wondering like this looks super crunchy. Like how could I make this better? The reason it looks crunchy is because it's operating only on it's operating only on the vertices that the model has, right? So like this model probably has roughly like 10 vertices across here. If you wanted more resolution, you would have to actually make a model that has more vertices to get a higher resolution. ShaderLab kind of encapsulates HLSL. So actually they're right. There's a whole bunch of built-in functions. Not Unity docs, no. You go to HLSL, you just look up HLSL docs. Fairly certain. This is the site. So I just Googled like HLSL docs and then probably like built-in functions. I don't know. HLSL built-in functions. HLSL reference. I don't know where you could just find them somewhere. I don't have them on lock. All right, so how do the colors transition between the vertices? Right, so I should probably go over that. It uses, okay, so you know if you have like a picture, like if I go into Paint right now, and I like make a picture that's like 10 by 10 pixels, and I like draw a smiley face. Hooray. And I just save that in like my download. And if I actually view this, you're gonna notice that it like looks blurry like this, right? So what this is essentially doing is it's doing the same sort of thing for the information in here. So if you're sampling a pixel that's in between vertices, it's gonna basically try to interpolate the vertices in a similar way. So each vertex has its information, and then based on the distance of like where the pixel is in between the vertices, it'll like try to interpolate that information, which is a bit funky. But as you can see, like as you can specifically see on these like cross sections, like these little lines here, is where it's like peaking because it's crossing a boundary of like which vertex it's interpolating from. Things like, so yeah, that's how that works, and it's very, very useful. There's some other information that you are able to get. For example, things that you need to request from the model, you need to request from this app data struct. So if you want, for example, let's get the UV value. I don't remember, I'm pretty sure it's text chord 0. I could be wrong. Let me take a quick gander. Meters. Yeah, so text chord 0 includes the UV. I'm gonna yeet all this stuff for now and just output a vertex normal. All right. Uh-oh, I just realized something. This is not a VR ready shader. I missed some things, and that's my bad in the actual example shaders. Let me see. Where is it loading these? Ooh, that's not good. Okay, I have a couple things I have to fix. These should have been VR ready. Let me show you how to make them VR ready, because this is probably going to be important. Literally any other shader but this one. So you need this in the app data to make it VR ready. You need this, and you need this in the V2F. And then in the vertex, you need to replace V2FO with this. And that's it. Now it's VR ready. UV. Oops. I need to specify that I want the UV in the output like this. I need a float 2 because it's 2-dimensional. I'll explain what the UV is in a second. If we try to output v.uv, it's going to error because it says cannot convert float 2 to return type half-4. Okay, so if we return 1, the reason this works is because it's basically interpreting it as doing this. This shader is wanting 4 numbers as output, and HLSL automatically assumes when you do 1 number that it's just going to fill a vector with all those numbers. But if you do 2 numbers like i.uv, which is 2-dimensional, it's going to be like, what do you want? So we have to actually, if we want to display this, then we have to fill the first 2 numbers with the UV, and then we can do the. This will be UV will be red and green, and then blue will be 0, alpha will be 0. And now we can see the UV. So what the UV basically is it's texture core. It's basically where you are on the faces of the object, and it's arbitrary and exported probably by your modeling software. Usually it's used as texture coordinates. So if you're sampling a texture, it's like where on the texture should I be sampling. So for example, like this would be 0, 0 on the texture. This would be 1, 1 on the texture. More complicated meshes will have different UV values. This is how it decides to use the texture on a cylinder. These are just built-in Unity meshes that you can use. Yeah, UV mapping. This is how you use the UV values. So like, if I wanted to use a texture, first of all, I have to pass it in. Or I should go over properties first. So for now, I'm going to show you how you can just set up, like, for example, from the inspector, we want to pass in a color. Say we want to pass in a color, right? And we want to animate the color in the inspector. So how we're going to set this up is we're going to have the name of the property here that we want to call it. So we're just going to call it _color. And then this is how it will, this is the name that will display in the inspector. And then this is the type here. And then we want color. Color is the type. And then we have the default value. So we're just going to set the default value to, we don't want alpha because that will be glow. So this is a property that, like, now that we've set this, we can go in the inspector, and as you can see, it's there. And it's saved, it's the same name as when we were using Poi, so it's going to be green still because it remembered that, because it was saved in the actual material file. Now, in order to use this in the actual shader, if we try to just use it right away, it's going to be like, I don't know what the hell that is. So we need to actually define it in the shader, in shader world, like this, and then the inspector will pass it in to variables with the same name. So this has the same name as this, so it'll be passed in. And then now we can use it, and then look at that, the color shows up, beautiful. And we can just change it however I want. And I'm going to demonstrate that this will actually show up in Beat Saber now. We just press F5. Yippee, yippee. I don't want alpha. And then now it won't go anymore. Hooray! We have a green thing. There we go. Okay, and we can do whatever we want. We can really just screw around as much as we want. Like, we can just take, like, okay, we have the UV value. Let's just, like, float forward. Let's, I don't know. We're gonna make a new color and just mix it between, like, I don't know, red and the final color based on the UV. I'm gonna explain this in a second, but, like, I don't know, we can pretty much just completely ball out here. So this is just like taking, this lerp function is going to be your best friend. It's taking this is the minimum and this is value A and value B, and it's blending between value A and B based on T. So when T is 0, it's going to be value A. When T is 1, it's going to be value B. So based on the X value of the UV, we're going to be mixing between just a constant value of red that I've just hard-coded here and the color from the inspector using this lerp function. And then we just output that. We can combine our silly thing from earlier as well. So we can just like float for local position. And then we're gonna just like local position dot y plus equals vertex or sign put that John in. There we go, and it's happening, but we can't see it, so we're gonna pass it in again. Float height, and then this is where we add a 1 because we've already used 0. And then now we assign it, and we're shipping it over, and this doesn't exist because we have to make it there we go. And then we can like take the height and like multiply it or something. I.height, please. We're back. They do not do HSV lerping. Shaders are trippy to get a handle on. They'll take a little bit of practice to think this way and create visuals this way, but it is possible. I can break down if you do you guys want to, is there anything else that you want to know in terms of shaders? Do you want me to open? I can open, if you want, I can open my project and show you how I achieved the effects in my map. I think I'm going to do that. I'll show you how my map works. Yeah, we can make it pretty. I'll show you, like, I don't know, maybe we want to put some like stars on this or something. So what we're gonna do, if we want like some randomness, I have this noise function, this library here. Then we can use the UV value, like this noise function, this noise thing has like a bunch of different noise functions we can use. So like noise functions allow us to basically have like a bunch of make a bunch of black and white blobs based on a position. So like this 2D noise will just like, we can put in the UV or something and out comes like a color, or out comes a value between 0 and 1, and it kind of like is like smooth randomness. It's like what Minecraft uses to generate its hills. But like, for example, we can make like, we can use simplex is what I'm calling. We can use the UV And then like if we just debug this by outputting literally just this value, you're gonna see it's just a bunch of random blur like this. But what we can do is like scale the value up, like the coordinate system up, but like we can scale the whole system, all the coordinates up by just multiplying it by a lot. Because if you think about it, like if we have our coordinate system here, this is a 1D example, just multiply it by something. It essentially compresses the space, because like, for example, if we multiply it by 2, then something that would have been 1 is now 2. So it like progresses everything faster. So now our whole system is going to be a lot thinner here. Are there any good library of shaders I could potentially look at / use? How does the hot reloading work? Hot reload, it reloads automatically. Like it recompiles automatically. Or the hot reloading for Beat Saber. Right here you can see if you press F5 you can build a version and compress. So I'm pressing F5 and then it's building, and then like I just reload in game. Whoops, there we are. And it glows because it's filling the whole thing with white when it gets. Yeah. Yeah, there's plenty of options. I've got examples in here for you to use. You can. There's Poiyomi, but we had issues with that earlier. I don't really like using Poiyomi. I'm pretty sure I might have been using an outdated version as well. But anyway, we have our noise function. We can, like, for example, I don't know, add to the color. Maybe we want to add the noise as, like, red. And then we want to, like, make the noise a steeper. That is. So, a lot of different strategies you can use here. So it's a bit silly. I'm going to basically explain what this is in a sec. Oh, brother. I don't want this going below 0. Go, yeah, yeah. Now we've got little stars on our guy. And I didn't reload, so I should probably do that. Like, maybe that's how you make, like, stars or something. Boom. 3. Okay. So, what I just did, I did a lot of things. I'm kind of running circles around this because I've learned to do this type of thing a lot. This height value was going below 0, which was causing, like, when I was adding new colors on top of it, some of the colors were more in the negative than others. So when I was adding to it, like, different channels were not synced. Or like not like some channels were higher than others because some were more into the negatives than others. So I just made it so that the height can't go below 0. This is how you do that because it's kind of counterintuitive, but if you take if you use max, this is sort of like your minimum number it can go before it will just get clamped. So nothing can go in the negatives here. Yeah, the taskbar, my whole graphics driver crashed, so I have to restart my computer. And then I basically just took the color I got from the noise and I like made it steep as hell. So imagine going into like Photoshop and like, you know when you can adjust curves? Like, okay, let's see. Let's see what I actually did. So like when you go into Photoshop, this is your range of colors, right? And if you don't do anything, then this is what this is, you know, it's just a straight line. But if you want to increase the contrast or like you want to increase the curves, and you just do this. Oh, this is the range. My bad. So this is what we're essentially doing by bringing the color, by multiplying the colors by itself. Is it's like the only way for it to show any brightness is if it's like really bright, like near 1. Is there any way to debug shaders? I like to just return. So like if I'm like if this doesn't if something doesn't look like I expect, then I'm just gonna go earlier and just like return certain variables and see if they look like how I expect. But like in terms of like placing breakpoints and stuff, no, you can't. Unfortunately not. There is RenderDoc. You can look into RenderDoc, which offers some better debugging functionality. But I'm not too familiar with it, and I'm not going to give a tutorial on it right now. And it's also not really practical to hook into it in Beat Saber. You'd only be able to do it in the Unity project. Okay. Give me a moment to pee. I'm going to load my Unity project, or my map project, and then I'll show you how things done by 6. We're so back. Here's the project. I'm gonna close the other project and close MS Paint and close my. Actually, no. I'm gonna open Writer for this project instead. This window. Thank you. Is there any? If there's any crucial shader effects that you want to see in a base shader library, what would they be? That like. So I'm pretty sure most of that already exists. Like Poiyomi, if you can get it to work, should allow you to create pretty much any material that you want in terms of like physically inspired, or maybe there's some additional options. If you want really specific effects that will require a bit more engineering in terms of like you got to go in and write the shader yourself, or you might have to go find the asset on the asset store if it's something more specific. It's kind of hard to like, there's lots of resources out there. The biggest problem is the alpha issue, where alpha equals glow in Beat Saber. You have to really understand that and potentially modify the output of the shader to have no alpha. But if then there's transparency as well, that becomes an issue. Are the visuals we're seeing right now operating on a mesh? Yes, they are. Like I said, everything's a triangle. Or everything's triangles. So I'll show you. Here's my ribbons. I'm gonna do shaded wireframe. Right, so in Blender, I pretty much just made this strip. And then I imported it into Unity as a model. And then the shader, first of all, the Vertex shader does the wobbly stuff to it, like I showed before, very similar. Hello. does the wobbly stuff to it. And in the shader I pass this z coordinate that I call the inflex point. This is the point roughly at which I want all of these to diverge. So how I do that is I say, like, as the z value approaches this inflex point, I'm going to take the x and y values and shrink them. And I do that in the vertex shader. So no matter where I move this strand is always going to diverge to 0 at this spot. I don't know how well you can see that. Let's look at an example here. No matter where I move this, it's going to head towards the center. So that I can make them diverge to one point here. Also, everything is a sphere. The sphere, yeah. So the sphere is pretty complicated in terms of the visuals, like how I. It's a lot of parts. I'm gonna blow my nose. Give me a sec. Okay, how I can break down the visuals for this sphere is so imagine, wow, this is a funky resolution to be working with. Is it backcalling? Yeah, it is. I think I actually inverted the normals in Blender, which was probably not what I should have done. But I didn't want to mess with the model after I had, like, because I had the vertices, like, focus, or, like, kind of, I had them set up a certain way that made them have a visual identity in the intro, and oh my god, this taskbar. Can I, like, restart Explorer? Or is that gonna cause this? I'm not gonna risk it. It works. Oh, what? It fixed everything. Yay! Never mind. I'm gonna undo everything. A bunch of stuff that I changed that I don't want to be changed. Unity, try to work. Of course, it's gonna add these meta files. Thank you. Whatever. Okay, I'll explain a bit of the concept for this sphere. In general, imagine we have our sphere, right? And imagine we're sampling this point on the sphere, and this is, here we have the z-axis, right? Z. If we're sampling this pixel on the sphere, I'm going to basically get the plane. Like, imagine on a plane that this point lies on. This is the this is the right hand side. This is the vector to the pixel. Imagine we get this angle and let's call it like theta or something, right? So if we're over here, then we're gonna have another plane that intersects it, and then we're also gonna have a different value of theta. And I use this angle to drive the color in a sense that, okay, I use something called, I use this function, which takes in a couple of parameters in order to create a palette. So a value from 0 to 1 will give me a different color. So I basically use the angle as the palette, or as the index for the palette, and I do various things to, like, distort this angle, like, based on the distance to the center. I also, like, add to the angle so that I'm able to, so that gives it the sort of twisty thing, because as it moves out, the angle gets added to. And then, for example, I add or subtracted the angle over time. So like I add like similar to how I was moving the plane up and down with the sine wave. I'm like moving the angle up and down with the sine wave. And then I'm also just doing little tiny distortions to it. And that's enough to already get really interesting visuals. Like, I might, hold on, I'm gonna go back to the testing project real quick, and I'm gonna like recreate this shader. I think that could be interesting. Get fucked. My skybox. Let's create a sphere, like so. Okay. Now, make a new shader. Bare bones. Skybox. Come on. This window. And I have to remember that I should probably put my make this VR ready. Okay, let's make this shader from scratch. So this noise or this colors function includes the palette shader I was talking about. I'm going to put 3 color. I'm going to make a function that outputs the color based on a t value. And return palette, and there's a couple parameters here that he uses. So we have a 0.5, 0.5 that'll fill the vectors out, and then I actually need to fill the vector out here. And then pass in t. Never mind, I pass in t first. And what's the problem, bud? Cannot convert. Okay. Right. So this has to be a float 3. Yeah, so pretty much. Yeah, you can use modifiers. You can do like you can use Vivify to pass in materials. Is you one of the maps that uses audio link? No, it does not. I haven't used audio link, so I can't really speak on that. First thing I'm gonna do, I want in my vertex shader or in my fragment shader, I'm gonna want the local position. So I'm gonna pass that information from fragment shader 3 local position, and remember that we're getting that from the input to the vertex shader. So this is the same thing. I'm also going to just pass it straight up. All right. So now in here we have our local position. Now the plane that I was talking about here is literally just the coordinates. Since it's axis aligned, this vector is basically just its regular vertex position, but without the z value at all. So if we return to float 2, we're gonna call this we just output these values here, and then we actually make the material use a custom shader, and then we apply it. Oh no! It decided that it was going to apply to the skybox because I called it skybox. Good job, Unity. One thing I also need to do is make it, oops, front. Back. So we need to be inside and make it very big. Unless I am stupid. Maybe I did it wrong. Yeah, it is annoying. I'm gonna call it my sky. Okay, it's still not gonna budge. How about project settings, lighting? Is there a lighting tab? Window, rendering, lighting settings. There we go. Is this even using this material? I don't think I... Yeah, I wasn't even using this material. That's great. Okay. Front. I always get these backwards. But here we go. Now we're in. All right. So I believe what we're now seeing is for every pixel, you can see when we get to the as the x value is like right here, the x value is 0. As it goes past 1, you can see the red channel increases because the red channel is being holy is being filled out by the 1, or being filled out by the red channel, and then the green is the y value. Now what I'm going to do in order to get the angle, basically right now I have, oh my god, I have this vector and I need to get the angle. Dude, I'm gonna restart my file Explorer or Windows Explorer. This is ridiculous. Okay, we're back. We're back. I fixed it. What the hell was that? We're gonna use atan 2. We have to pass in the y value and then the z value, and then if we just return the angle, invalid subscript z. Oopsie daisies. Now we have the angle. I'm fairly certain it's going to it's -1 here, and then it's 1, or no, it's in radians. So it's going to reach 1 here. It's going to be at pi here, and it's going to be go all the way around to -pi. So what I'm going to do is float degrees, or float normalized angle. I'm going to take the angle and I'm going to divide it by 2 times unity pi. Unity pi is a built-in like value for pi. So now this whole thing should be between 0 and 1. It's going to go up to 0.5, and then it's going to go to -0.5. So then I'm going to add 0.5 to it, and now we should get, there we go, a value from 0 to 1 all the way around. Now if we just use this normalized angle and use it on the color function, I'm just going to make a color variable, float3 color equals, this is a terrible name, galaxy color, galaxy gradient. Yippee! Wow! Yay! I used the wrong numbers. So this is a rainbow, but I don't want a rainbow. I think it's these numbers instead that I want. And then now, nice. Okay. Glad that Unity shader language seems to be fairly familiar. Yeah. Okay. So now we have our skybox, like sort of like base color. Is anyone following, by the way? Is this sort of making any sense? What I'm doing? Yeah. So now we have this. This angle, we can add to the angle based on the length of I have two, no, based on this length. Okay, the VR ready part, you need this in the app data, you need this in the V2F, and you need this in the Vertex shader, and that's it. At least for regular, what do you call it? Shaders that aren't blitz shaders, or post-processing shaders. Okay, so now we have a thing twisting, and we get to play with this twist value. This is the wrong house. Now, I'm pretty sure what I've done, yeah, is a bunch of... I'm going to move this. I'm going to delete this. Get out of here. We can also add to this by taking the time value and just like running it through a sine wave. Okay, that's very intense. But now we've got some movement. And then we can also change the shift. So I'm going to go... I'm going to generalize this so we're not calculating it multiple times. Like, oh, something like this. So we're changing the phase of the sine wave by like adding the by using the distance from the center to like change it. Also, I just realized probably should be using xyplane.z or i.locoposition.z. And then now it will twist based on the z value. I also really want to just... There we go, we already got like something that's kind of close. You can see how I got there now. Because then I can like... HLSL. I don't know... But yeah, you can see roughly how I got to that point. And then I'm pretty sure I did the same thing again. By like just doing it multiple times. So I can say color equals 0. And say like flip 3 color 1 equals I can change the here. There we go. We got something crazy already. You probably don't want it spinning that much. But like already got something pretty interesting. Just by like banging rocks together. Just mix them multiple layers and there you go. And then we can just F5. Or I lied actually. Let's go prefabs. Let's call this Skybox or something. Put it in the prefabs folder, add it to the asset bundle. Press F5. Now in here, we reload the language server. And I prefabs dot skybox.78. And I need to pass the map. I'm silly. There we go. Now I reload, except for why is this on that side? Whoa, we're back. Go back. Yeah, there we go. Now you can make your very own homemade U ripoff. Is it possible to change the speed colors at a specific time with the shader? Yes, and I will show you how to do that. So let's say I'm gonna expose a variable in the shader up here. Let's call it _ brightness, and it's gonna be a float, and the default value will be 1, of course. Default value is in when you first create the material. I like to put my properties right above the vertex shader. We need to define it in there as well, and then we just multiply the output literally by this brightness value, and then I'm gonna make it a range as well, so you can do this to like make it a slider. This is minimum and maximum. Yeah, so I can show you how to, for example, now adjust this in the shader, or adjust this in game. So if we now export, well, I'm going to show you first that if you try to go to materials, you're going to see nothing. And that is because if you want to actually change the material, you need to also expose it to the asset bundle like that. And now once we export and we restart the language server, now we can see the skybox. And then we can use this set function, pass in the difficulty, and then here's the values we can set. So here's the brightness value. And we can set like to 0, and then this is the beat that now we can set the beat that it happens. So let's say at the beginning of the map we want the brightness to be 0. And then let's say later on at beat 1 we can also optionally provide duration. Let's say we want it to go from 0 at the beginning of the animation to 1 at the end of the animation. So same as before, value time. 1 is the end of the animation, 0 is the beginning. Dude, that's gonna trip me up. Okay. See that? We animated it. Whoa! Whoa! Can you set it to the base time? What's base time? You should make a video on just showing random examples of general shaders people might want to make. You see, like, saying shaders people might want to make is so, like, there's so many different directions you could go. There's an infinite number of different directions you can go. Like they say Minecraft is infinite, this is even more infinite. This is stupid, the amount of directions you could go. There's already shaders that you can use as a base, like Poiyomi, if you can get it to work. Or there's I know that in the shader, in the Saber creation project, there's a lot of shaders there that are VR ready and Beat Saber ready that you can use that are general and just like maybe a solid color, and then you can add like specular highlights to it and that type of thing. And then from there you can use a texture on it and do pretty much whatever you want. Ever tried using ray marching inside of Beat Saber? Rate marching is a bad idea to do in Beat Saber. It's very expensive, and not only is it expensive, it's double expensive because you have to do it for both eyes, which is not good when we already have a 3D rasterizer, which we can use to render things, which is way better. Yeah, here we are with we can also change like the twist as well if we want to expose like the amount of twist. You can just be like this or twist. Let's say 1. And we're gonna twist like I'm gonna capture this whole thing and multiply it by twist. And then now in the skybox later here. My god. Like the amount of twist. And maybe want to make it less bright. And then you can see like this is pretty much my map already. Can you... Oh, okay. From new modifiers, can you use... Yes, you can. I actually made that extremely easy to do. And I will show you how to do that in a second. For example, let's set the twist to that. So, for example, since we need this to be kind of done over a long period of time, the animation needs to be active. So we're going to start the animation at beat 0, and then we're just going to have it go over like the entire map. So it's like a really long duration, virtually infinite. I need to export again. And then I need to restart the language server. And then there's my twist value, yay! And then here we go, we got base energy, boop. So we want, the twist will be based on the base energy. And as you can see, when we're losing energy now, it actually changes the twist. So we just died, so there's no twist. It's kind of crazy, you can just do that now. This is not ReMapper, this is Unity. ReMapper is made in Unity though. So yeah, you can see the possibilities are ridiculous. Like, stupid big. I'm gonna show you how you can do stuff programmatically as well. So like, for example, if we want like every beat, oops, bruh. Maybe like every beat we want to just like flash the brightness for like half a beat. I'm gonna say between beats 1 and 20, I'm just gonna do this. And then we can do that fairly easily. So, boom, 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 boom. Except for I probably want to start it at 0 and end it, so it doesn't look silly. Good job, Arrow. You didn't actually finish the animation. And then also there's an easing. So if we want to ease out, this is basically the interpolation from this frame to the last, or this keyframe to the last. You can go to easings.net and see like what all the easings do. Like a regular and untouched easing would be like this. Like it linearly goes from this keyframe to the next. If you do this, then it's gonna like interpolate in the next keyframe like that. So now it's just gonna like go from this keyframe pretty much immediately to these values. There we go. So yeah, we can adjust the brightness like that through code. Cool example would be setting it to the head rotation or something. Maybe, yeah. Yeah, we'd be using Firefox. Yeah, you can make the environment more red as the health decreases. That's something you can do. Another thing you can do, by the way, this is kind of crazy. This is kind of crazy. Yeah, I'm gonna get rid of the flashing. My bad. I'm gonna set the brightness to 1 right away. rm.set or set global property. This does exactly what you think it does. So we can set to like redness. We can set this as a float, and we can set it to rm.runtime difficulty points linear. It's not going to let me do base energy. Oh, it gave up on giving me suggestions, apparently. Can you get only the Y rotation from the head? Yes, you can. So we can do... I don't know why it's not giving me suggestions here. Hold up. Runtime. Points. Linear. Runtime. Ah, that's why. Because I'm silly. Okay, so you can do base head rotate local rotation. I don't know if this works in FPFC. We can do .y or .x is going to be the pitch. And we're going to set the duration to like something huge. But for example, if we edit this shader now, we can just do float underscore redness. We don't even need anything from the inspector because this is a global property. So if we just output redness, like we just output it straight up. In Unity, it's going to be black because it's not set by anything. But as soon as we do this in Beat Saber and we reload script, which I think it should have done by exporting, not going to work because I'm in FPFC and it doesn't work. So I'm pretty sure in game that would work. Let's try base energy and see if that works. If I screw something up somehow. Nope, it works. In VR, this will work. I'm sure of it. Let me try Y. See if the Y works. I'm fairly certain it's based off of this camera, which is just facing forward, so all the values are default. FPFC is flight controls. But yeah, this is the way that you would do that. You can do swizzling, which is kind of awesome. I don't know, it's kind of annoying that doesn't... But, in any case, you could see with the base health that would actually work. Base energy. You could even use the... Look at all the things you can do. You can do environment color. You can use the base... I don't know what all these are. There's so many different things you can tap into. You can use the song time. So, you can like make it get red over time. This is probably not the way you want to do it. Wait, I don't know. Is this an inverse? How does this work? Use base head rotation. Base head rotation. Okay. Oh my god! Holy shit, we're back. Okay, that does actually work. And of course it's in degrees, so we have to divide by 360 in order to get it between 0 and 1. That's really funny. Oh, it's instantly like as soon as I pass over. Right, okay. It's it starts at 0 here. Oh my god, it works when I'm paused? What the fuck? I think what's happening here is that it's becoming 360 immediately. So, oh, how do you fix that? Because it's like wrapping around. Whatever, you get the idea. It is actually reacting to my head. Yeah, it's kind of insane. What's the hype behind swizzling? It's really funny and looks funny and works funny. And it lets you take, like, I would not, if I try to use base rotation like this without getting the X component, it's not gonna work. It's gonna throw an error. Yeah, see? Float modifier point have 2 numbers. Expected 2 but found 4. GPU effect is going to work when possible. It's about it's Vivify passing that in. So it's about whether the custom event is still active during buzzing. So that's kind of interesting. But anyway, okay. What else could we use? What else could we look at? Post-processing effects. Let's do post-processing effects. Okay, let's make a post-processing effect right now. Create shader, Vivify, blit, my blit. Okay, here we go. This one has actual shader support, so I didn't screw that up. Good job. All right. By default, what we can do is we have our main camera. We add in the utilities folder. There's this script called simple post-processing. We're just going to drag that on, and then we get to pass the material that we're going to use. So let's make a material. Let's call it my awesome shader. That's a terrible name. My blit. And we're going to apply the material we just made. Then we're going to go to the camera, and this is just for preview purposes. As you can see, it's just going to do nothing at first because it's just returning the color. But you may notice that now we get to control what the actual output color is. So if we just multiply by like 300, it's going to be cooked. Oh, yeah. Yeah. Oh, yeah. Oh, yeah. You say y'all, it was just me. I did a lot. All of this, like, examples and stuff was all me. But actually, wait, UG Echo did the shader templates. I forgot. A lot of this, the examples were me. He did the shader templates. Yeah, you're right. My bad. I just stole the credit live. Canceled. The Google Doc is happening now. Okay, so we have the screen color. What if we want to invert color? There we go. Now we can invert color. So, or let's say that, like, we want to multiply it by the X value of the UV. So, like, as it gets closer to the edge of the screen, things get darker. And then we can make that effect more noticeable. So this allows you to do, like, yeah, canceled. This allows you to do post-processing effects, give you the screen, like, lets you do a pixel shader on the entire screen. And that's pretty much how this shader is set up. So, for example, what is screen UV? I'm not even using this. I don't remember what this is. Compute screen pose. This is probably not used anywhere. Whoops. Oh, this was for grab pass. Oh, we got so much stuff we gotta fix because I'm stupid. I made a bunch of dumb decisions. Okay, because I was rushing. The template. There's a bunch of issues with the template. A simple chromatic. Do you want me to do chromatic aberration? All right, let's do chromatic aberration. Okay. All right, so we have our UV value is like, let's just return the UV value. So this is our UV value, right? Starts at 0, goes all the way to 1. Starts at 0, goes all the way to 1 on each axis. So it allows you to sample the screen texture, and also output the color that the screen will be using at any given pixel. So this fragment shader is going to go over each pixel, and you get the UV value, and then you can sample the screen or do whatever you want. So let's build up a color here. How we're going to make how we do a chromatic aberration is we basically offset the color based on each channel. So we're gonna sample the texture at different places for every channel. So float x equals. We're gonna get the for the alpha and for the green, we are going to just do regular old UV. For the red, we're going to offset it a tiny little bit to the left. For the blue, we're going to offset it a little bit to the right. And then we're just going to return the color. And whoa! This is a terrible example of how to do this, actually, because you can barely see anything. Maybe I did this wrong. I am stupid. Wait, no, I'm not. Yes, I am. I forgot to take the corresponding component. I still did it wrong. This is linear, because Beat Saber uses linear. Things look very wrong. Oh, because I'm sampling up a bunch. I am silly. There we go. Okay, you see the little bit of... what we can also do is, like, amount. Chromatic aberration. Chromatic aberration. I'm going to set this to, like, a float. Make it 0, or make it 0.1. What is your problem? Rename to... Yeah. Now I'm going to add this into my shader, and then we are going to put it in here. And now we get to change. Whoa. We should put a cube, you're right. And make my camera... Okay, let's make it 0, 0, 0. There we go. I'm also going to make this arrange to make it a little bit. This will be saved as a VOD. You are good. All right, there we go. Pretty basic chromatic aberration. This is like extreme, so I'm gonna have it be 0.2 at the most. There we go. We just got some very slight splitting. So if we move, we have to view it through the camera, by the way. If we try to view it in the main view, it's not gonna work. It has to be through the camera. Oh, which kind of sucks. But if we like move the camera, we can split it up. Look at him. All right, so now we have to expose this to the shader as we learned before. F5, go into our thing, reload. Now we can materials dot myblit dot blit, and look at this, I made it all nice for you. Isn't that so wonderful? And then we just have literally the beat and the duration. So we're just gonna do it right away at beat 0, and then we're just gonna keep it on forever. Boom, and then it's literally as simple as that. Look at that. Boom, made your very own Mawntee map for free. I'm going to get rid of this redness thing I did for the skybox, though. Be gone! And then now I'm not using it anywhere, I think. I'm gonna export it. Hold on, I'm gonna take a look at chat in a second. I'm kind of locked in, though. Boom! And of course, as well, the material is also exposed. So if we want, we can animate the amount of distortion. We can animate the amount of chromatic aberration through ReMappers or through Vivify as well. So, like, if we really want, materials.myblit.set chromatic aberration, we can, like, animate this. Started off at 0.2 and then or 0.11 and then set it to 0 at the end of the animation. And do that like at beat 3 or something, 5 or 6 beats, and we're gonna see it spike up. Look at it diverging. Oh my god, that's so cool. Okay. Do dynamic bones work? What happens when you sample negative? Hold on, different questions. Do dynamic bones work? I don't really know. That's like the animation system, I'm assuming. If you can put it in an asset bundle, then yeah, it works. What does material.set return? Oh yeah, it returns a set material property event. So this creates a set material property event and then also gives you a reference to it. Make it so you can reference the property name in the actual event thing? What do you mean? What happens if you sample negative? Okay, I mean, it's just gonna swap, like red will just be on the left side instead of the right side. Like if we just, oh, it's not gonna let me. Yeah, it's not gonna let me. But I can demonstrate. It's still not gonna let me. I think I screwed. This is the wrong shader. That's why. Yeah. Just. What do you expect? Alright, there we go. Boom. Oh, if the UV is negative, the UV will not be negative. Oh, you mean like at the very edge if it goes, oh, it wraps around or it clamps. So if you try to sample off of the texture, off of the screen texture, it just extends it. I can show you this. If I just take the UV and I just like multiply it by 0.5 or multiply it by 2, it just extends it, which you can't really see that well with this setup. There you go. Now you can see. Yeah, it'll just extend it. It's quite funny. So let's actually try this. I'm really curious how this looks in game. Oh my god. So yeah, there's our screen in the bottom right, and then this is just gonna extend it. Okay. All right. That looks awful. Yeah, I mean, It's not gonna look good. My god, this is so trippy. Does anybody want... Is there anything anybody wants me to know? Does anyone want to know how to do anything? Now's the time to ask. That will probably give somebody a seizure. Get rid of that. Can you attach scripts to objects? No. That's the only limitation. How do particles work? Okay, I can go over particles. Stuff that renders in one eye would be interesting to know. That would be a preprocessor directive, if I am not mistaken. So I don't know which one it is. Or you can get the index of the eye somewhere, and then you can do control flow based off of that. You know how this? Okay. There's a couple questions. I'm gonna go from the top. Can you attach scripts to objects? No. Okay, I can go over particle systems. Let's go over particle systems. Light or effects particle system. Okay, here we go. These particle systems right out of the gate are not going to work for Beat Saber. So let's make our own shader that works well. Standard shader, my awesome particles. Open that John up. This one's nice because it includes a texture right away. So this will just work out of the box, if I remember correctly. Except for it won't, because I forgot to put the making it VR ready. That's my bad. So here we go. This is an exercise. Except for you won't have to do this because in theory I would have not fucked it up. Alright, now we make a material. Particles, yay. Particle system. In the renderer is where we put the material. Now we're going to configure the material to be the shader that I just made. Now we're going to pick your favorite particle thing. Now you might notice this has no transparency. Transparency would be good to know. So let me explain transparency to you. Since we can't use alpha equals glow, we have to use a blend mode for transparency. And there's a couple examples of this. So for example, if we go to the examples folder, we go to scenes, there's opacity. And you can see how we use brightness as transparency. So here's how this shader works. We have blend. This is the line that does the magic. And also this, you need to do this as well. So if we want it to be transparent at all, we have to format this nicer. I don't like it being on one line like this. This is going to say you're going to render during the transparency stuff, so you're going to render after geometry, and the render type is also going to be transparent. So I believe the difference with render type, this is just from my observation, so take this with a grain of salt. With transparent things, I forgot. I low-key forgot. You'll never know. We need to do this as well. And we also need to turn Z right off. So this will not... What this means is that we won't write to the depth buffer. I'll show you what happens if we don't have this. And if we go back to our funny little scene with our particles. Hi. If we don't have this, I'm going to pause this. Look at how this particle is cutting off this other particle. This is because it is writing to the depth texture. Meaning it's going to say, hey, I'm here, and then when this particle's drawn, it's going to be like, I can't draw here because because something has already drawn. Imagine a texture. Like this whole screen has an invisible texture that you can't see. that stores the depth of information. So when this was drawn, it stored that it was like for example these pixels, it was so and so distance to the camera, and then when this is being drawn, it calculates its distance and it says is this less or more. If it's less, then it can draw because something earlier wasn't already closer. But if something was already closer, then it won't draw, and that's how things end up being behind each other in games. If we turn Z write off, then it will never write to the depth texture, and it won't be able to block other objects from rendering. But it can still be blocked by objects because it's still reading the depth texture. So like if we have a cube, we make it very big, and then we move it over here, you can see like, you know, it still has proper depth. If we turned Z test off, then it would not care about depth at all, and it would just render over everything. We don't want particles or anything transparent to write to the depth texture. But yeah, what this line is doing is it's blending based on the color. Meaning the brighter it is, the more opaque it will be. For a bit of a breakdown of how this is working, you can see this is pretty much the output. This 1 and this 1 minus source color, 1 multiplies with the source pixel, so the pixel that's coming out of your fragment shader, and then this is the existing pixel, so the pixel that's already on the screen. It's basically saying like, how should I create the new destination pixel based on like what should I multiply these colors by in order to create the new destination pixel. So we're saying we're going to take the source pixel and we're going to leave it alone. So the pixel that comes out of the fragment shader, we're going to leave it alone. And the existing pixel, we're going to subtract from it the values of the pixel coming out of our vertex shader. So if this value is 1, then the existing pixel will just become 0. And we're just going to end up with the output being 1. If our source pixel is 0, otherwise, like there's no brightness, then we're going to do 1 minus 0, so which is going to be 1. So our existing pixel will just be 1. Our source pixel will be 0. So we're going to end up with 1. And then now imagine doing that for every channel. So TLDR, it basically blends based on how bright the color is. Hi, Lilybug. Yeah. That's how the particles work. And then we have various options to like make the particle system spit out particles in different ways and make them adjust colors over time. Now teach us stencil. I could teach stencil. Stencil is funny. I don't understand stencil super well, but it's pretty useful and sort of advanced, but okay, let me show you how we can like, okay, so for example, the emission is coming out of like a little cone. There's all sorts of options here. We can make it like a donut. We want it to be a donut. Then we can make the particles come out of there. We can change the emission. So right now it's just going to constantly do 10 pixels, 10 per second. So if we set this to 1, I'm pretty sure it'll do 1 a second. 1, 2, 3, 4. If it's 2, it's going to be like 1, 2, 1, 2, 1, 2. You get it. If we want all the particles to spawn at once, we just do a burst. Boom. We do another burst and then make it happen later at time 2. So it's going to spawn 1, and then it's going to spawn another one in like right now. So the donut, and then you can adjust like the donut radius or like the donut radius or like the donut thickness. And then yeah, there's pretty much like this is all Unity stuff, so you can just like look at the particle system docs and then make particles epic style. And then like maybe you can like change their size over lifetime by like using this curve and then making it go like this, and now they're gonna get smaller as they get older. Look at them, they're disappearing. Ring of fire around the player. Yeah, you can do that. You can like literally, let's do that. Just make it like this. And then like we want them to pretty much just be, let's see, we want them to just be going up. So velocity over lifetime. Let's go say the start speed is gonna be like 0. So they're just gonna spawn right there. And then we're gonna make them go up. That is not up, cuh. There we go. So this is like pretty much fire. Ooh. In this case, we're probably just gonna want the shape to be a circle. Boom, much simpler. There's already like a radius thickness. Force fields are also a thing. Force fields are pretty fun. I haven't messed with them too much. But yeah, and then like I don't know, you could have like a fire texture or something, or you could make a shader. I don't have a fire texture on hand. I can make it the Total BS logo. Never mind, I can't. Because it uses transparency, not darkness. My bad. I don't know what this thing is, but you can do it. And then I can also just like make it, I don't know. You could do, yeah, velocity over lifetime. Like, it's just gonna keep adding this to the velocity of, I think why, it seems like, I don't know why this is Z up. But there we go. You can do random between 2 constants. Make it like random for each individual particle. Ooh. And then like, yeah, if we want to import this, you know, same old procedure, particle system. Add that John to the bundle. F5. Restart language server, prefabs dot particle system dot instantiate. Restart. Whoa! Oh my god! Okay, there we go. We've got a new top chart. Wow, this is so cooked because all the colors are peaking. Unity and Blender, these are not... This is all Unity. Did you make something like a flame and attach it to notes? So it depends how you want to do a flame. I mean, I'm going to make... The way that I would do a flame is probably procedurally, which is probably not the way that a lot of people would want to do it. You can go find like a flame shader and then make sure it's not outputting alpha. Here, you know what? Let's make an actual fire shader right now. I'm gonna make a new shader. Let's call it like fire. I can't put exclamation marks. And I'm going to put again this in here. Boom. No, the thing is that like usually Y is up, but in the particle system for some reason Z is up. Look, the Z is up. What? When did it get rotated? What the? Yo, okay, well that explains that. It got rotated. I don't understand how that happened, but Unity decided it was time to rotate it. Or maybe I decided and I just forgot. Okay, how are we gonna make fire procedurally? I have to actually think about this. I'm gonna definitely need noise. We're not gonna need colors. I'm just gonna output 1 for now. We're gonna use... We're gonna make a value that comes from like simplex i.uv, and we're just gonna add to it the y value over time. And now we're just gonna output this and see what happens. Except for this material is like not using it, so we have to like make fire material or fire general, and then now our particle system, we're gonna use that instead, unless I can't drag anything because I'm stupid. Oh, there we go. And then now I'm gonna use shader fire. Okay, you gotta trust. This is a trust the process moment. Okay, you gotta trust the process for this. We're gonna use. I'm gonna sample the UV with the UV. We're gonna sample the noise with the other noise. Whoa! It's so fancy! And then we're also gonna move that down, except for at a different pace. Now what we can do as well is say v minus equals this is really weird. I think what we want is okay, now we have a UV that's in terms of the center, because basically it was like 0 here and it was 1 here. So I multiply it by 2, so then 0 here and 2 here. And then I subtract 1, so this becomes -1 and 1 here. So that's what I did. Now we return length, enter UV, and this should give us a funny circle. We're so back. Now we want to invert it. Now we're back. Now I'm gonna like make it smaller. Circle. And then we're gonna do return circle like times 0.3 or something. Bruh. Okay, yeah. No, I lied. I need to change the scale of this first. Okay. I think what the shape that I want is I want like a whoosh. So maybe I lied. So we're gonna get this value, and we're gonna 1 minus that. We're gonna subtract i.uv.y. Okay, we're so back. Now we're gonna take the interesting. Now we're gonna invert it. This is like really odd. Look, I think I don't want. This is like we're getting there. We're getting there. We're getting there. We're getting there. This is too intense. How did I make fire with no tutorial? Because I am fire. Okay, now we have this like center UV. We're gonna... I'm just gonna... Okay, we need to... I'm not gonna lie, I'm not even communicating much right now. I'm just like kind of locked in, so hopefully you guys are okay with that. The only issue is that every single particle looks like the same flame. Also, I'm gonna like... I feel like this, okay, that looks really good. Now we just need to color it. And also make this, like, less... Yeah. Make it a little bit more good. Maybe you can take the roll position. I have a better idea. So we're going to learn custom vertex streams right now. You ready? Oh my god. Okay. So custom vertex streams, I don't care about anything except for the UV in the position. And I'm going to pass. We just need an X value, okay? So we should be getting testcore.xy, testcore.z. Okay, so we're gonna pass. I'm gonna change this. How do I move? How do I move? How do I move things? Help! Oh my god, okay, I'm not gonna be able to just move this line. So awesome. Okay, now we assign it. Okay, so basically this is going to let us, right here, custom vertex streams, we're passing things right into the vertex shader through Unity's particle system. And it passes it, it tells you what it passes it in as. So text chord 0, xy is the UV value. So we're just going to take text chord 0, and then we use xy as the UV value, and we use z as the random value here. And then we can pass it into the vertex, to the fragment shader like this. And then I'm basically just going to, like, a lot. I'm just gonna do this. Oh my god! Okay, maybe that's too big. I'm running enough floating point numbers. Okay, look at that. All of them are different. Okay, so the issue now is that we have a one-dimensional output and we want color. So we're gonna do float 3. We're going to, I'm gonna use this again. Actually, we can do something simpler than that. We're going to do color, out color. So we're going to input what the different colors of the flame will be. Now we can return color. This will now work first try. Okay. I must think. Looks so bad. I need a gradient that starts at black. I've got an idea. Hold on. Make a function. I'm locking in. I'm locking in. I think it's good to see this process. So for the first, I'm gonna add 0.5 and multiply by 0. So in theory, if I just output use i.uv.x. Okay, we're almost there. I forget. What is out color rate? Even get influence. Okay, there we go. And then I might just leave it and see how it reacts. Good. That's what I want. And I'm going to Yeah, we're so back. This is like so scuffed. This is not a good fire shader, but like we're getting somewhere. I mean, I'm getting... Literally, yeah. You can just cook it up. I'm just changing random garbage now at this point. Oh, you're right. Maybe. You might be right. Oh my god, you're right. Wait, that made everything work. Oh, wait, that actually looks like real fire almost. That's so silly. Okay. Okay, now we add the blend mode. We add our transparency. Or we actually add all of this. Boom! Wow, that's actually good! That's actually good! Oh my god, you just saw it live! That's actually pretty good, dude. That's sick. Alright, now we have the Ring of Fire. This is too much orbital velocity. You gotta calm down. That fire is fire, you're right. Now, what we can do as well is we can use this V value as the alpha, and it'll glow, but it'll still be transparency as hell. Alright, now we have to... Now, I'm pretty sure this will just work, and I'm gonna not blit anything anymore, because, oh my god. Goodbye. I don't want to spawn the particles. I don't want to spawn the skybox in either, so... Okay, I think I did not build, unless I am mistaken. Oh, I gotta apply overrides, my bad. So basically I made changes to the prefab outside of the prefab, which meant that like those changes were like on top of the prefab. So I had to like go in here and say like, actually you need to apply this to the prefab. We're so back. What the hell? Why is it white? Oh, I know why. I need to make the alpha steeper. It needs to be like really filtered for the alpha because it's starting. It just becomes white. Okay, I need to make the bottom not ass. There we go. Yippee! Holy shit, we made fire. You don't need no. I don't need a tutorial. I can just make fire. That's actually so sick, though. That's kind of fun. But yeah, you can see how like that's actually really good. I'm actually really proud of that. I just took noise and then added and then used the noise to sample more noise. That looks like real life. Besides the line in the middle, ignore the line in the middle. That's just the brightness. I need to round off the brightness. I'm using this, which I would want to... let me Desmos it up real quick. I love Desmos, if you couldn't tell. I basically want this. So I want to bring it to the power of like 0.3. Bruh. Oh, my bad. That should get rid of, like... There, that line should be gone. We're back. Yeah, a lot of shader effects are noise. You're right. The issue right now is I'm kind of like the X value is like... I'm doing this, so I want to like round it off. I'm doing like... I want to round it off. I think what I may do, I think I have a... I'm not logged in. Give me a sec. I did not sign in with the right account. Okay. I want this function. I need to implement this. Or I can do smooth step. You know what? Okay. Why am I doing this? Did I mess it up? I might have gone bald. I think I want to 1 minus this. Real. Perfect, I fixed it. I'm like totally like just doing random garbage now. Anyway, fire shader, everybody. This could be improved to actually make the colors not. For sure. I can publish it, yeah. I can just upload it somewhere. Why did it become so circle? I kind of reduced the tapering a bit. Basically, like... I can make it like 0. A little bit more. Or I can even... This is good enough. We can also adjust the start size. 3D start size. Be like more thin. Look better. fire! Hooray! Okay. Does this explain things? Hopefully, like me, just you do if statements in a shader, yes, but it's generally frowned upon because GPUs are designed to do things in parallel. So if you start adding branches, then it like holds up the whole thing. I mean, it's not the worst thing in the world, but it's like generally you want to avoid it. Yeah, there's also preprocessor directives, which is basically like it'll actually change what the shader ends up being based on certain things. Like, for example, you can enable or disable a feature from a toggle in the inspector, and then that will like allow you to include or exclude certain parts of the code. There's so much to learn with shaders, but there's so much fun to be had, in my opinion, if you make the shaders yourself. I am not good at modeling in Blender. I am the shader guy. I am not the guy. Yeah. Somebody could recap it. I don't think I have the energy to do that. Yeah, there's a lot of depth. Like, I'm showing pretty surface level stuff you can do. You can continue to like push the boundaries. There's some pretty insane stuff you can still do. But yeah, I mean, being able to program visuals is like the coolest thing ever. And hopefully I've shown you enough features of Vivify to make you comfortable starting your own project and creating things. Does anyone have any more questions? Because like maybe I should end the stream. Yeah, I mean, I sometimes do get into this stuff and then like it's... Is there a Vivify Discord? There's the Heck Discord. I didn't get into Grab Pass. Do I need to get into Grab Pass? I think there's already enough examples of Grab Pass or in the Vivify template. I have to go fix things in the Vivify template because apparently things got very broken. Is there documentation? Yes, there is. Well, for what? ReMapper or Vivify or Heck? There is ReMapper wiki. There's a whole wiki full of things you can do for like literally everything you could possibly want to do. Okay, yeah, and then there's also Vivify. Basically all of the events. Unity has its own documentation. Huh. I wonder who would make glass. Nobody would be crazy enough to do that, right? Oh, thank you, Unity Hub. You're not responding. Okay, I can close the program. does this button ever actually work? Oh my god, it worked. Too late for object prefabs, like object overriding, like custom notes? Probably. I think I'm gonna end it soon. If anybody has additional questions, let me know. Like off stream. I think I have taken up an incredibly large amount of time. There's a GUI program where you can define notepad. It would. True. But currently, the way we're doing it is the most stress-free way. Oh, hey, look at that. That's this trail thing. Oh, I really want to explain the trail because I'm so proud of the trail. But like, that's for another time. But man, that trail was so cool. It's a combination of it uses a vertex shader to basically like generate a path in real time between like based on the control points of the saber and the saber's position, and then also the world position of where the actual controllers would be. It's really sick. Okay, that's where I'm gonna end it for today. Thank you everybody for sticking around. We've had like 30 concurrent viewers the entire time, which is kind of insane. Hopefully this will be enough to motivate people to get into Vivify and make cool things. And hopefully you can start looking at like, oh, what's this? Okay, it's just a bunch of noise, and then there's also the angle, and then we did this with the skybox. We made a rainbow based on the angle. And then like, I don't know, you can just look at stuff and figure out how it works maybe. Flag, Melanie. Is that trail Voronoi? Yeah, it is Voronoi. You can see the cell pattern, but also like very distorted Voronoi. Thank you everybody. Bye.